Welcome to Sleepy Stories. Get comfortable, close your eyes. Tonight, we're going to feel the solid ground beneath you take shape from a whisper of cosmic dust. Picture yourself adrift in the velvet quiet of space, looking down upon the Earth. It is a familiar world of deep blue oceans and soft, swirling clouds, turning with a silent, steady grace. You have seen this image countless times, the symbol of home. But tonight, we will gently turn back the pages of its story. We will drift backwards in time, watching as the lights of cities fade and the shapes of continents rearrange. We travel further still, past the age of pyramids and empires, past the reign of the dinosaurs, until the great forests they roamed recede into spore and seed. We will journey beyond the very first breath of oxygen that tinged the ancient air, and before the first drop of water ever fell as rain. We are travelling 4.5 billion years into the past, to a time before there was a world at all, only a vast and patient darkness. The world you know is the final chapter of a story of immense and patient creation, shaped by countless gentle gatherings and slow transformations. Its record lies in the layered rock beneath your feet and in the salt of the ancient seas. It is a story that began not with a sound, but with a slow, gravitational turn in a vast cloud of interstellar gas and dust, and it quietly culminates in you resting here tonight, a living part of this planetary history. For the carbon that forms your architecture, the calcium that gives your bones their strength, the iron that enriches your blood, all of it was forged in the heart of a star that lived and died long before our sun was born. These elements were scattered across the galaxy in a final, silent, blossoming release. Tonight, we will follow those elemental grains on their immense journey. We will trace them from a cold, quiet nebula adrift in the interstellar dark, through the gentle warming and coalescing of a new solar system, through ages of ice and fire, all the way to this very moment in this peaceful room. This stardust, carrying the memory of its stellar crucible, drifted for eons through the silent cold. It was a patient, unhurried migration through the dark, a slow gathering of cosmic dust and gas that would eventually form the cradle for our own sun and its worlds. So, allow your breathing to be slow and steady. Let the world outside this moment fade into a comfortable distance. We are about to drift back to the very beginning, to a time when our solar system was just a shimmering, slowly spinning disk of possibility in the vast, quiet expanse of the Milky Way. You are floating in an immense and silent darkness. This is not the familiar dark of a country night, but an absolute black, untouched by any nearby star. You are suspended within a molecular cloud that extends for scores, perhaps hundreds, of light years. Even light needs generations of human lifetimes to cross it. Here, somewhere in the cold interior of this expanse, you drift among fine dust and thin gas. The cold is a presence, a deep and permeating stillness. It is not the biting cold of a winter wind, nor the sharp, dry cold of an Antarctic night. This is a cold that borders on the absolute, just a few degrees above the theoretical point where all motion ceases. At 260 degrees below 0 Celsius, gases that you know from home have long since frozen into solid crystals, clinging to dust grains like frost on a window pane. The very atoms around you are lethargic, vibrating with an ancient residual energy that is slowly, patiently radiating away into the void. The dust is unimaginably fine. If you could hold a pinch of it, it would feel smoother than silk, making talcum powder seem coarse. These are grains of silicate, the stuff of rock and sand. There are specks of carbon, the fundamental building block of life. And coating them all are delicate mantles of ice, not just water ice, but frozen ammonia, methane, and carbon monoxide. Each microscopic particle, smaller than a bacterium, is a remnant of a star that lived and died long ago, its ashes scattered through the galaxy to become the seed of new creation. And there are trillions upon trillions of them, a diffuse fog of potential, drifting in the near nothingness. They move so slowly, so independently, that you could watch for 1,000 years and perceive no change at all. This magnificent structure is a giant molecular cloud, a stellar nursery whose changes unfold over millions of years. For now, it appears to be little more than cold, nearly motionless dust. Yet this is the raw material from which gravity will build a star and its worlds. From your vantage point deep inside, you cannot see the stars. The cloud is too dense, too opaque. It swallows the light of the distant galaxy, allowing only the longest, reddest wavelengths to filter through. The effect is a dim, uniform, claret-coloured glow, like a permanent twilight seen through a veil of smoke. Space has no medium here, dense enough to carry sound to your ears. Nothing disturbs the slow drift of countless particles, and yet, even here, in this profound stillness, change is stirring. Far away, on a scale you cannot see, a star much more massive than our own has reached the end of its life. You do not witness the event. The light and fury are lost in the intervening ocean of dust and gas. But you can feel its consequence. An invisible shockwave, a ripple of pressure from that distant cataclysm has been travelling through space for millennia. It is not a violent blast. By the time it reaches this quiet corner of the cloud, it has weakened and spread, becoming less of a cosmic wrecking ball and more of a gentle, persistent push. A cosmic sigh. But it is enough. This subtle compression is the catalyst. The dust and gas particles around you, which were once held in a delicate equilibrium, are nudged just a little closer together. It's an infinitesimal change, but it allows the weakest force in the universe to finally take hold. That force is gravity. Gravity is patient. It does not rush. It simply pulls, constantly and universally. And now, in this slightly denser patch of the cloud, its pull becomes ever so slightly more effective. The process is unhurried, playing out on a timescale that defies human comprehension. Dust grains acquire icy mantles and gather into loose, fluffy aggregates, rather like snowflakes in the dark. Around them, the gas contracts into denser knots. Pebbles, boulders, and planetesimals will come later, once a spinning disk has formed around the young sun. For now, the whole region is collapsing, and the greatest concentration of material is building at its center. You feel yourself drawn towards it, a current so slow it is almost imperceptible. The entire local region of the cloud is falling inwards on itself, a gravitational cascade that, once started, cannot be stopped. As the material piles up at the center, the pressure begins to build. The core of the collapsing cloud starts to warm, the potential energy of the falling gas and dust converting into heat. This initial phase takes 1,000,000 years. It is the cosmic equivalent of watching a mountain erode, a process of immense power masked by its own slowness. You have the gift of deep time, the ability to witness eras that make all of recorded human history seem like a single fleeting breath. The heart of the cloud is no longer dark. It glows with a dull, deep red, an ember in the cosmic night. This is the protostar, the embryonic sun. The pressure at its core is now unimaginable, crushing hydrogen atoms together with such ferocity that they begin to vibrate with intense heat. The temperature climbs steadily. 1,000 degrees. 10,000. 100,000. It continues to rise, past 1,000,000 degrees, towards the critical threshold. And then, in a silent, luminous moment that will define this corner of the galaxy for the next 10 billion years, nuclear fusion ignites. A self-sustaining fire is kindled in the heart of the cosmos. The sun is born. It is not yet the calm, steady star you know. This is a young, volatile star in what is known as its T Tauri phase. It sputters and flares, rotating rapidly and blasting its surroundings with a ferocious stellar wind. This outflow of particles acts like a great cosmic broom, sweeping away the remaining gas and dust from its stellar nursery. You watch from a safe distance as the nebula that birthed it is blown outwards, its hazy veil evaporating to reveal the structure that has formed in its wake. What remains is a vast, flat, spinning disk of material orbiting the newborn star. This is the protoplanetary disk. It is made of all the dust, rock, and ice that was not consumed by the sun, the cosmic leftovers, the construction site rubble from which new worlds will be built. The disk is hotter near the sun and cooler further out, creating distinct zones of creation. You find yourself drifting within this spinning plane of debris. Near the fiery young sun, only materials with high melting points, like metals and silicate rock, can survive. Further out, beyond a demarcation known as the frost line, it is cold enough for volatile compounds like water, ammonia, and methane to freeze into ice. This simple temperature gradient is the reason our solar system has rocky planets in its interior and gas and ice giants in its outer realms. All around you, the process of planetary formation, called accretion, is underway. It is a slow-motion dance of construction. Irregular lumps of rock and metal, known as planetesimals, tumble through the void. One, perhaps the size of a small country, drifts into your view. It is not moving quickly, but in the frictionless environment of space, momentum is everything. Another, of a similar size, is on an intersecting path. You watch as they lazily approach, and when they meet, they do not shatter or bounce, they merge. The energy of the low-speed collision melts the rock at the point of impact, fusing the two bodies together. The new, larger object, its mass now doubled, continues its unhurried orbit around the sun. This is how planets are made, through countless encounters rather than one dramatic event. Dust gathers into larger bodies until planetesimals begin merging into protoplanets, first the size of moons and then of small worlds. And somewhere in this disk, about 150 million kilometers from the central star, a particular protoplanet is growing with remarkable efficiency. It happens to be in a favorable orbit, sweeping up the material in its path, clearing its lane through the cosmic debris. It is in the perfect place, the so-called Goldilocks zone, where the temperature from the young sun is just right, not so hot that water boils away, not so cold that it remains forever frozen. This world is pulling in more and more mass, its gravitational influence growing with every collision. You drift closer to this embryonic world. It is perhaps half the size of the Earth we know today, and it is not yet a perfect sphere. It is a lumpy, misshapen ball of rock, glowing with the tremendous heat of its own formation. Every impact has deposited more energy, and its entire surface is molten. You are looking at a global ocean of magma, a sea of liquid rock churning in slow, convective currents. There is no crust, no solid ground, nothing to stand on. There is only the searing, radiant heat of a world being born, glowing in shades of orange, red, and yellow against the black of space. This is the Proto-Earth, 4.5 billion years ago. A nameless, lifeless sphere of molten stone, orbiting a temperamental young star in a solar system still thick with the chaos of creation. Its surface slowly radiates heat, and its heaviest elements, iron and nickel, are beginning to sink through the liquid rock towards the center, forming a dense metallic core. A process called differentiation is giving the young planet its internal structure. It is a world beginning to find its form. As you watch this nascent world, you can almost feel the slow, inexorable pull of its gravity. The process of differentiation is a silent, planetary scale sorting. The heaviest materials, drawn by this growing gravitational field, are migrating inwards, a journey of millions of years towards the planet's heart. This migration releases yet more heat, keeping the magma ocean in a state of constant, sluggish motion. Lighter silicate materials, destined to one day form the mantle and crust, remain floating on the surface. This gradual settling brings a sense of order to the chaos of formation. The world is organizing itself from the inside out, establishing the layered structure it will carry for the rest of its existence. For a time, it seems this gentle, radiant cooling is the planet's destiny. But the calm of this glowing sphere was not to be its final state. In the busy, crowded pathways of the young solar system, another journey was unfolding, one that was destined to intersect with our own. You are floating in the silent, star-dusted vacuum of space, a quiet observer to a world in its infancy. Below you is the Earth, some 4.5 billion years ago. But it is not the familiar blue and white marble of today. There is no surface to stand on, no ground to feel beneath your feet. There is only a global ocean of liquid rock, a sphere of magma stretching to every horizon, glowing with a soft internal heat of thousands of degrees. The sky above it is a profound and perfect black, the black of a world without a whisper of an atmosphere. No air, no clouds, no oxygen. Just the silent emptiness of space pressing down upon the molten world below. The sun is here, but it is a younger, more restless star. It shines with a less generous light, a little smaller and dimmer in the void. From time to time, it throws out great tendrils of energy, flares that would scour the surface of any world unlucky enough to possess life. But there is no life here, not yet. Biology is still hundreds of millions of years in the future. For now, chemistry and physics are playing out across a young world of molten rock. The planet turns with a speed that seems almost dizzying. A day, from one sunrise to the next, may last only a few hours. The Earth is spinning rapidly, conserving angular momentum from the countless smaller collisions that formed it, rather like a dancer pulling in their arms. The youthful sun rises and sets, then rises again, each cycle of light and shadow a swift rhythm in the darkness, and it is in that darkness that you begin to notice something new. There, on the horizon, a new light is dawning. It is not the sun. This is something else, something that does not belong. It rises with a steady, inexorable purpose over the glowing curve of the Earth. It is a world in its own right, a colossal sphere of red and orange and yellow, and it is growing larger with every passing moment. This is another planet, a lost wanderer of the early solar system, a world roughly the size of Mars, tumbling on a long, graceful and unalterable collision course with the young Earth. Billions of years from now, astronomers will give it a name, Theia, for the Greek Titaness who was the mother of Selene, the goddess of the moon. But in this moment, it has no name. It is simply a cosmic traveller, a world of rock and iron, moving at nearly 40,000 kilometers an hour, about to meet the world shimmering below you. You watch it grow, a silent, luminous giant. It begins to fill the sky, its sheer presence blotting out the distant, unfamiliar constellations. It is not a perfect sphere. As it draws closer, you can distinguish mountains on its surface, and the scars of impact craters from its own formative eon. It is now so close that its own inner heat is palpable, the glow from its own magma ocean casting a warm reddish light upon the Earth. Its surface ripples and churns, a mirror of the world it is about to meet. There is a terrible and profound beauty in its approach, the kind of awesome, humbling beauty one finds in the patient power of a glacier, or the slow, inevitable turning of a galaxy. The molten surface of the Earth begins to stir in response. The liquid rock below you starts to bulge outwards, drawn up by the immense gravitational pull of the approaching world. These are tides, but on a scale that is almost impossible to comprehend. Great silent waves of magma, miles high, are being lifted from the surface of the planet. The young Earth groans and deforms under the strain, a deep, resonant vibration that you can feel through the fabric of space itself, even though there is no air to carry the sound. And then they touch. The two worlds meet. In the first fraction of a second, the released energy turns solid rock into incandescent vapor. Beneath the impact, their dense metallic cores are thrown into violent motion. A shockwave of unimaginable power ripples outwards through the bodies of both planets. You watch as the surface of the Earth, the entire global ocean of magma, leaps into the sky. It does not splash. It is lifted. Continents of molten rock, each one the size of a mountain range, are hurled into the blackness of space. Some pieces are thrown with such force that they escape Earth's gravity forever, destined to wander the solar system as lonely meteoroids. Others arc upwards for thousands of miles before falling back, adding to the sublime chaos below. Thea does not survive this encounter as a separate world. It does not ricochet away. The two planets become one. Their molten bodies flow together, their liquid surfaces merging into a single, larger ocean of fire. Their heavy iron cores, drawn by gravity, sink towards the shared center, mixing and swirling together. The resulting body is a new Earth, larger and more massive than before. It is hotter, its internal furnace stoked by the energy of the merger. It is a world reborn from a cosmic crucible. But not all of the material from this union remains with the new Earth. A significant portion, perhaps a tenth of Thea's mass, is thrown outwards by the glancing nature of the collision. You watch it stream into the void, a spectacular, spiraling arm of molten debris, each droplet and boulder glowing like a miniature sun. Some of this material escapes into the wider solar system, and some rains back down onto the roiling surface of the planet. But the vast majority, the great bulk of this ejected matter, is captured by gravity. It does not escape, nor does it fall. It remains in orbit. Slowly, it forms a ring. Not the neat, icy ring system of Saturn, but a dense, chaotic, and ferociously hot disk of vaporized rock and metal. It encircles the newborn Earth, a luminous halo of creation. Within this churning ring, the countless particles begin to collide and recollide. Gravity, the great sculptor of the cosmos, begins its patient work. Tiny droplets of condensed rock stick together, forming larger pebbles. Pebbles merge into boulders. Boulders coalesce into vast planetesimals, hundreds of kilometers across. You drift through this field of debris, watching gravity and momentum reshape it. In traditional debris disk models, the material gathers into the Moon over years or centuries. Some newer, very high-resolution simulations produce a Moon-sized satellite directly within hours of the impact. The details remain debated. Either way, on a geological clock, the change is almost immediate. One large body settles into orbit around the Earth. This is the Moon. In these first moments of its life, it is a staggering sight. It hangs in the sky much, much closer than it is today, appearing many times larger than the Sun. It fills a vast portion of the heavens, a colossal sphere glowing a deep cherry red from its own residual heat. Tidal forces will soon synchronize its rotation with its orbit so that it keeps one face towards the Earth. Its immense gravity pulls relentlessly on the planet below, creating tides in the magma ocean that dwarf even those raised by Thea's approach. Vast, silent swells of molten rock, hundreds of meters high, slosh back and forth across the globe. This constant flexing and kneading of the planet acts like a brake, dissipating energy and gradually, gently, slowing the Earth's frantic rotation. Over the coming millions of years, this tidal interaction will continue. The moon will be pushed slowly outwards, inch by inch, year by year, stealing a tiny amount of Earth's rotational energy to do so. The days on Earth will grow longer, calmer. The moon's steadying presence will stabilize the planet's axial tilt, preventing wild swings in climate and creating the predictable seasons that will one day prove so crucial for life. But for now, it is a close and fiery companion, a lasting reminder of the most formative day in Earth's long history. You float in the space between them, the Earth and its new moon. Both are luminous, both are molten, and both are now, ever so slowly, beginning to cool. As they radiate their primordial heat into the cold of space, something remarkable begins to happen on the surface of the Earth. A skin begins to form, not a solid crust, not yet. It is just a thin, fragile layer of darker, cooler rock, floating on the sea of magma below. It is constantly cracking, splitting apart, and being swallowed by the furnace, only to reform elsewhere. It is a delicate, shifting membrane between the planet's inner fire and the outer void. This dark, basaltic rock is the first stone, the first true ground, and then it begins to rain. It is not a rain of water. The surface is still far too hot for that. But the solar system is still a busy, chaotic place. Asteroids and comets, their orbits disturbed by the giant planets, continue to fall towards the Earth, drawn in by its strengthened gravity. This is the beginning of a long bombardment, and many of these comets are rich with ice, with water locked away in their frozen hearts. As they strike the molten or newly crusted surface, the ice does not melt. It vaporizes in an instant. Great plumes of steam, of water vapor, rise into the blackness above. Molecule by molecule, impact by impact, this vapor begins to accumulate. Earth is slowly building its first atmosphere. It is not a breathable one, of course. It is a thick, heavy blanket of steam, mixed with carbon dioxide and other gases released from the cooling rock. But it is a start. You watch this process unfold over uncounted millennia. The constant rain of cosmic debris continues, delivering both water and new rock to the growing planet. The sky, once a perfect black, slowly softens to a hazy, perpetual grey. The surface, once a brilliant orange, slowly cools to a deep, angry red, and then to a dull, dark glow, punctuated by fresh lava flows and the brilliant flashes of new impacts. This is the Hadean Eon, a name we have given it from a future vantage point, after the mythical underworld of the ancient Greeks. And for the next 600 million years, the Earth will be a world of fire and shadow, undergoing a profound and gradual transformation. You feel the air itself growing heavier around you, thick with steam and ancient gases, holding the planet's fading heat close to its hardening skin. You sense this growing pressure in the atmosphere, a colossal weight of water vapor waiting for the world below to finally become cool enough. Yet through it all, the planet is cooling, degree by patient degree. The crust is thickening, the atmosphere is growing denser, and as the temperature of the surface continues to fall, it is slowly approaching a critical threshold, a point at which something impossible, something miraculous, is about to happen. A change that will set the stage for everything that is to come. You are standing on what passes for solid ground, a foothold gained, perhaps for the very first time in the planet's young history. The rock beneath you is a thin, dark crust of newly cooled basalt, and a rare, ultramafic stone called comatite, a rock so rich in magnesium it could only form in the impossibly high temperatures of this primordial age. This fragile shell floats upon a global ocean of magma, a treacherous surface fractured by a network of deep cracks that glow with the infernal orange of the molten world, just centimeters below. You can feel the immense heat radiating upwards, a constant oppressive warmth that makes the dense air shimmer. This is not a stable place. It is a world in the process of becoming, its very surface perpetually unmade and remade. But for the first time, in this fleeting moment of solidity, the concept of grounds has found its meaning. Above you, the sky is a thick, suffocating blanket, the colour of a deep and sullen bruise. It is an opaque, churning mass of gases released from the planet's molten heart, an atmosphere with a crushing weight you can feel in your bones. There is no blue, only a murky, reddish-brown haze of carbon dioxide, nitrogen, and vast quantities of water vapour, all laced with the acrid tang of sulfur compounds and carbon monoxide. This is not air as we know it. It is a primordial cloak, utterly devoid of free oxygen, trapping the planet's heat and shrouding the surface in a perpetual, gloomy twilight. The sun, still young and some 30% fainter than it is today, is not a distinct orb but a diffuse, barely perceptible brightening in the oppressive canopy overhead. Lightning forms a constant flickering web across this sky. Arcs of electricity crackle between clouds of volcanic ash in the upper atmosphere. Fine silicate particles rub against each other in the turbulent air and build a colossal static charge. When that charge breaks, the dense atmosphere carries the thunder efficiently across the landscape. Shimmering sheets and ground-shaking strikes light the world in brief, violet-white pulses. And the volcanoes. They are not distinct mountains on the horizon, they are the horizon itself. The planet's crust is so thin and brittle that magma finds its way to the surface almost without effort, through countless weaknesses. You are surrounded by low, broad shield volcanoes, their gentle slopes built up over millennia of fluid eruptions, and by long, gaping fissures that bleed lava directly onto the surface. You can watch as a new crack opens in the rock nearby, a glowing wound from which molten rock wells up, spilling across the dark plains. It flows not like thick honey, but with the terrifying speed of superheated water, an inexorable river of fire that consumes and transforms everything in its path. As it cools, it forms new black stone, a fresh patch on the planet's ever-changing skin. The landscape holds destruction and creation in the same view. Slow-moving rivers of lava, glowing from within, carve incandescent paths through the older, darker rock. Cliffs of basalt that have stood for 1,000 years, a veritable eternity in this age, are undermined and collapse into the molten flow, vanishing without a trace. Nothing is permanent here. The entire surface is caught in a cycle of volcanic resurfacing, a geological canvas that is wiped clean and repainted on timescales of mere centuries. The planet is shedding its primordial heat, not just from the violence of its initial formation, but from the fierce internal decay of short-lived radioactive elements like aluminium-26, and the slower, steadier warmth of uranium, thorium, and potassium trapped deep within its core and mantle. This internal furnace keeps the interior ferociously hot and the surface in constant turmoil. You look up into the hazy sky and see the moon. It is a breathtaking sight. It hangs there not as a small, distant disk of pale light, but as a colossal, detailed sphere, appearing far larger than it does in our modern sky. It is so close that its surface features vast, dark plains of solidified magma, and the faint outlines of giant craters are visible to the naked eye. Its gravitational pull is immense, a silent, powerful force shaping this young world. The Earth is spinning much faster then, a day lasting only a few hours, a dizzying rotation that whips the clouds into planetary-scale storms. The moon's proximity raises colossal tides, not of water, for there are no oceans yet, but tides of magma within the planet itself. The entire world flexes and groans under the moon's influence, a rhythmic squeezing that further stresses the fragile crust, triggering earthquakes and fueling the endless volcanism. Yet even in this seemingly eternal furnace, the seeds of a different future are being sown. In pools of slowly cooling magma, Deep within the crust, tiny crystals are beginning to form. They are zircons, exceptionally resilient grains of mineral forged under immense heat and pressure. Each one that grows here is a microscopic time capsule, locking within its crystalline structure a chemical snapshot of the environment in which it was born. Billions of years from now, geologists will find these very crystals weathered out of their parent rock and preserved in the ancient sandstones of Western Australia. By decoding their chemistry, particularly their isotopes of oxygen, they will uncover a truth that once seemed impossible. They will find the unmistakable signature of liquid water, a ghost of a cooler world hidden within the heart of the fire. You see the evidence for yourself now, not as an ocean, not even as a pond, but in the subtle signs of a world beginning to change. In low-lying areas where the crust has had a moment to cool and thicken, you see steam billowing from fissures in the rock. These are the planet's first geothermal vents, its first fumaroles. As the superheated vapor, drawn from deep within the mantle, hits the cooler, dense atmosphere, it condenses, leaving patches of moisture glistening on the dark stone. It is the first wetness on a world of fire, the first hint of the blue planet that is to come. A hydrological cycle, the most delicate and vital of planetary engines, is taking its first faltering turn. Slowly, almost imperceptibly, the temperature of the surface is beginning to fall. The cataclysmic bombardment of asteroids and comets that characterized Earth's infancy is tapering off. The largest impacts, which could vaporize entire oceans before they had a chance to form, are becoming rare. The cosmic shooting gallery is, at last, falling quiet. The Moon, our constant companion, continues its gradual, outward spiral, and as it recedes, its tide-raising power wanes, allowing the planet's interior to settle and the crust to thicken. The Earth is finally radiating more heat into space than it is generating and receiving from impacts. It is cooling, hardening, maturing. You make your way across the surreal terrain, climbing the gentle slope of a low, dark shield volcano. The ground crunches underfoot, a mixture of glassy, obsidian-like rock and loose, porous scoria. From the summit, you gaze out upon a world painted in a severely limited palette. Black and grey rock stretches to every horizon, punctuated by the distant, sullen, red-orange glow of active lava flows. Above, the sky is a uniform, oppressive ochre, brown. Nothing yet is green or blue. Molten rock moves beneath an atmosphere that no human could breathe. But then, your eye catches something different. Far below, in a wide, shallow basin formed by a long-dead impact, a shimmer, a glint of reflected light that does not glow with its own heat. You descend the volcano, your curiosity pulling you forward, and walk for hours across the barren, cracked plains. As you draw closer, you understand what you are seeing. It is water, a lake. Perhaps a mile across, it fills a vast depression in the basalt, a pool of liquid gathered under the bruised sky. The surface is perfectly still, undisturbed by any wind, reflecting the hazy heavens like a dark, flawless mirror. You kneel at its edge. The water is incredibly hot, not quite boiling but close to it. It is likely acidic from dissolved volcanic gases, and saturated with minerals leached from the surrounding rock. But it is stable, it is liquid, and as your eyes scan the landscape, you see that it is not alone. Other, smaller lakes dot the lowlands, each one a testament to the great change that is underway. The water vapor that has saturated the atmosphere for millions of years is finally condensing and falling as rain. Not a gentle shower, but a heavy, scalding downpour that hisses and steams where it strikes the still hot ground, pooling in every crater, basin, and depression it can find. This is the moment of transition. The Earth is ceasing to be merely a ball of molten rock and is beginning its journey to becoming a living world. The Hadean Furnace is giving way to a new eon. The crust is stabilizing, the bombardment is ending, and the water, delivered by countless comets and asteroids from the cold depths of the outer solar system, is finally finding a permanent home on the surface. For millennia, it has been a planetary-scale deluge, a constant hot rain falling from the sky. Standing at the edge of this primordial lake, watching the steam rise gently from its surface, you realize the profound continuity of this substance. These very molecules of hydrogen and oxygen began their journey in the vast, cold, interstellar clouds that predated our solar system. They were locked in ice for aeons, delivered to Earth in a torrent of cosmic impacts, and then spent millions of years as vapor in a superheated atmosphere. Now they have pooled in this quiet lake. In time, they will form the planet's oceans, its ice caps, its clouds, and its rivers. And eventually, they will flow through the veins of living things, becoming the blood, sweat, and tears of all future generations. As you linger, the sky seems to brighten. The volcanic haze is thinning. With the planet's interior calming, the relentless outgassing is slowing down, and the heavy, toxic atmosphere is slowly beginning to clear. The faint light of the young sun feels a little more present, a little more direct. And through the thinning veil above, as if a curtain is slowly being drawn, you can see the faint, distant pinpricks of stars for the very first time from the surface of the Earth. The air itself feels different now. It is still dense and warm, but the acrid sting of sulfur has begun to fade, replaced by the clean, damp scent of water vapor. This gentler atmosphere carries the promise of change, a sign that the planet's long, violent fever is finally breaking. Above you, stars sharpen as the steam thins. Below, the damp new crust releases its stored heat into the scattered lakes gathering across it. You lie back on the dark, warm rock, a solid foundation on a world that is finally finding its peace. Looking up at those ancient, silent stars, you feel a sense of immense patience. The stage has been set. The most vital ingredient has arrived. The next, and perhaps most extraordinary, chapter in Earth's long story is about to begin, as these scattered, lonely lakes start their slow and steady journey to becoming a single, global ocean. You are standing on a shoreline that should not exist, on a world still taking shape. The sand beneath your bare feet is not the pale gold of future ages, but a deep velvet black. It is made of volcanic glass born in fire, then shattered and tumbled by the tireless waves for millennia, ground down into these fine, dark grains that feel cool against your skin. The ocean stretches out before you, a vast, restless expanse of olive green, its surface agitated by an endless procession of whitecaps marching towards the shore. Above you, the sky is a uniform ceiling of cloud, but these are not the choking clouds of ash and sulfur from the planet's violent birth. These are impossibly heavy water clouds. Rain defines this part of the story. Repeated deluges sweep across dark rock and feed the growing ocean. With no plants or soil to slow it, water runs directly over bare basalt and gathers in every hollow. Its steady hiss fills the empty landscape like immense white noise. This planetary rain has its origins in the heat of Earth's formation. As the young world radiates energy into space, the immense volume of water vapor released into the atmosphere begins to cool and condense. Across millions of years, repeated deluges fill craters, basins, and fissures in the cooling crust. Scattered lakes overflow, merge and expand until they become a single, unrecognizable entity. An ocean. The first true ocean. It covers almost the entire surface of the planet, leaving only the very highest volcanic peaks exposed as lonely, isolated islands. You wade into the water, and the first thing you notice is its surprising warmth. It feels like stepping into a bath. The planet's core is still a furnace of molten rock and metal, and that immense heat bleeds steadily upwards through the thin young crust, warming the global ocean from below. There is no ice to be found anywhere on this world. The poles, which will one day be locked in frozen slumber, are as warm and temperate as the equator. The great ocean currents, the planet-girdling conveyor belts of heat that will one day dictate global climate, have not yet begun to flow, for there are no significant temperature differences to drive them. The world's ocean is, for now, a single, placid, featureless body of warm water, a global bathtub. The water is not clear. It is a cloudy, greenish-grey soup, thick with dissolved minerals. The ceaseless rain has spent millions of years scouring the naked rock of the protocontinents, leaching out salts, silicates, and vast quantities of iron. This dissolved iron gives the ocean its unsettling olive-green colour. It is salty, but not with the sharp, familiar salinity of the seas you know. That concentration will take billions of years of evaporation and runoff to achieve. A slow process that will one day make the ocean taste of tears. For now, its taste is more metallic, more mineral, the flavour of a world still being dissolved. You swim further out from the black sand shore. In the lee of a nearby island, the water is calmer, protected from the wind that scours the open water. An island. The first true land. It is the cone of a colossal shield volcano, its summit rising just a few hundred feet above the waves, a stark silhouette of black basalt against the grey sky. It is steep, jagged, and utterly barren. There is no soil, grass, or lichen, and no animals occupy its tidal pools. You see only stone beneath the grey sky and water moving against it. You dive beneath the churning surface and follow the island's volcanic slope. Suspended sediment thins as the light fades from grey to black. Far below, a faint orange glow flickers in the abyss. You have found a field of hydrothermal vents. These are deep fissures in the thin ocean floor, gateways to the planet's molten heart. Here, seawater seeps down into the crust, where it is heated by magma to extraordinary temperatures before being ejected back into the ocean. The water erupting from the vent in front of you is not merely warm, it is superheated to over 300 degrees Celsius. At the surface, it would instantly flash into steam, but down here, the immense pressure of the overlying ocean keeps it in a liquid state. It erupts from a chimney of rock in a shimmering, turbulent plume, carrying with it a rich payload of dissolved minerals from the hot rocks below, sulfur, iron, zinc, and copper. As this superheated fluid meets the cooler surrounding seawater, these minerals precipitate out, creating a billowing cloud of fine, dark particles that looks like thick black smoke. And here, in this seemingly hellish environment of total darkness, extreme pressure, intense heat, and toxic chemistry, something truly extraordinary is taking place. It is not yet life, but this environment offers unusual chemistry. Mineral surfaces and microscopic pores can act as catalysts, while chemical and thermal gradients provide energy. Laboratory work suggests that settings like this may help simple molecules form more complex organic compounds and membrane-like structures. Whether such reactions led to the first cells here remains an open question. You cannot see the individual molecules, but you can sense the chemical potential in this dark, warm place. Replicating life is not here yet, and no one in your own time knows exactly where or how it will begin. Hydrothermal vents are one leading possibility because they provide energy, mineral catalysts, and sheltered pores. Other hypotheses place the decisive chemistry in warm pools, on mineral surfaces, or in shallower water. The earliest surviving evidence of life will appear hundreds of millions of years later. For now, the vent shows you one plausible route from simple chemistry towards something more organized, without revealing where that route will ultimately lead. You return to the surface, breaking through the green-grey water into the misty air. and you notice something has changed. The rain has stopped. For the first time in what feels like an eternity, the percussive hiss is gone, replaced by a profound quiet, broken only by the gentle lapping of waves against the shore. The thick blanket of cloud is beginning to break apart. It is not clearing entirely, but it is thinning, and through the slowly widening gaps you see it. The sun. It appears pale, a little smaller and less fierce than it will one day become, its light filtered and softened by the high wispy clouds. But it is unmistakably the sun. For the first time in millions of years, its direct light is touching the surface of the ocean. The water sparkles as tiny ripples catch the pale sunlight. A world of black and grey now has a silvery surface. No living eye is here to see it, but you can imagine the quiet dawn spreading across the first ocean. All around you, the islands are growing. More volcanoes are breaching the surface, pouring out lava that cools into black rock, adding to the landmass, slowly building the planet's first protocontinents. For now, they are just scattered archipelagos of dark volcanic rock. But they are becoming more stable. Deep beneath them, the crust is thickening and differentiating. The planet is sorting itself out by density. The heaviest elements, iron and nickel, have already sunk to form the core. Now the lighter elements are arranging themselves. Dense, dark basalt forms the floor of the oceans, whilst even lighter rock, granite, is beginning to form, the buoyant foundations of the future continents. You walk between two of the islands, a shallow strait connecting them. The water is only waist deep, and the floor is smooth, black stone, still warm to the touch from the planet's inner fire. No fish dart away from your legs, no seaweed brushes against your skin. The silence is eerie, punctuated only by the rhythmic shush of the waves and the distant, deep rumble of a volcano adding another layer to a growing landmass. On one of these islands you find something remarkable. In a shallow depression in the rock, a pool has formed, cut off from the main ocean. The water here is even warmer, heated directly by the volcanic rock it sits upon. And the water itself looks different. It is cloudy, with a distinct greenish tint. You lean closer, and in the clear, geothermally heated water, you can see the cause. Bacteria. Early life. By this later point in the story, the threshold from chemistry to biology has been crossed somewhere, although the surviving evidence cannot tell you exactly where. In this sheltered, warm and mineral-rich volcanic pond, you are looking at colonies of tiny, single-celled organisms. They live, reproduce and evolve. These are not the oxygen-producing cyanobacteria that will one day change the sky. They draw energy from chemical reactions involving compounds in the volcanic runoff and thrive in conditions that would be hostile to most later life. You cup your hands and scoop up some of the water. To a casual glance, it looks empty, clear. But in the palm of your hand, you hold millions upon millions of living beings. They are the quiet, invisible conquerors of this new world. For the next billion years and more, these simple cells, and others like them, will have the planet entirely to themselves. They will change everything. But that is for the future. For now, they are just a strange, greenish scum in a forgotten volcanic pool. The great ocean remains almost entirely sterile. The sky is still a palette of greys. The planet is still settling, still finding its long-term rhythm. As you stand on the shore, watching the waves, you feel a change in the air. A breeze picks up, the first true and organized wind. It is not the chaotic, heat-driven turbulence of the Hadean, but a coordinated movement of air, a sign that the atmosphere is beginning to circulate. As the sun warms the equator, and the poles remain fractionally cooler, vast, slow-moving currents of air begin to form. Weather is being born. You can see it building on the horizon. A towering bank of dark clouds, climbing miles into the upper atmosphere. their immense forms lit from within by silent, flickering flashes of lightning. A storm is coming, and it is moving towards you with purpose. When it arrives, the wind is strong enough to make you lean into it, a physical presence. The rain returns, but this time it is driven sideways, stinging your skin. The waves are whipped up from gentle ripples into great rolling swells that crash upon the black sand with a deep, resonant roar. This is the planet's new pulse. Cycles of rain and sun, storm and calm. The ocean is beginning to breathe, its currents slowly stirring, distributing heat around the globe, shaping the climate, and carving the coastlines with its restless energy. This grand, rhythmic dance will continue for the next 4 billion years. Long after your time, long after humanity, the ocean will still be here, breathing in and out, its waves still shaping the shores of a world that is forever in motion. You find shelter behind a large, water-worn boulder and wait for the storm to pass. It may take hours, it may take days. Time is an abstract concept here. But eventually, as it must, the wind begins to soften, the rain lessens to a drizzle and then ceases, and the sun breaks through the clouds once more. The ocean settles, its surface becoming as smooth and reflective as glass. This endless cycle of erosion and deposition is a geological metronome, marking time on a scale almost too vast to comprehend. The very rock you shelter behind was once part of a towering volcanic peak, its sharp edges and rough surfaces gradually smoothed and sculpted by the persistent caress of water and wind. Every grain of sand on the nascent beaches is a fragment of a mountain, carried by rivers and currents on a journey that might last for millennia. The ocean acts as a great sorter, grinding down the hardiest of stones into fine particles and laying them down in stratified layers that will, in some distant future, become sedimentary rock. These layers will hold the story of this era, a silent testament to the world's first rains and the tireless work of its first ocean. You feel this immense, slow-moving power in the air around you, in the very ground beneath your feet. It is a world of elemental forces, a place of profound and patient transformation. The water that carves the land also carries the essential ingredients for what is to come, a planetary crucible in which the raw materials of the Earth are being dissolved, mixed, and rearranged. The planet is settling into a new equilibrium, finding its rhythm. And as the storm recedes, the evidence of this quiet, constant change becomes visible, not in the grand sweep of the coastline, but in something far more subtle. The pools of water left behind by the retreating tide are now perfectly still, their surfaces mirroring the clearing sky with flawless clarity. And in that perfect glassy reflection of the sky, you see something new. A subtle shift in the water's colour. The olive green of dissolved iron is still there, but it is joined by another tint, the faintest, palest, most delicate hint of blue. The chemistry of the ocean is beginning to change, and with it, the chemistry of the atmosphere. A new chapter is about to begin. You are standing in the shallows of an ancient sea, the water barely covering your ankles. It is warm, lapping gently against your skin under a sky that is not yet blue, but a soft, hazy orange tan. Before you, a vast tidal flat stretches towards the horizon, shimmering in the light of a younger, dimmer sun. The ground beneath your feet is not sand, but a slick, gelatinous mat, a living carpet of microorganisms that yield slightly with every step you take. It has a curious organic smell, a mix of salt, sulfur, and something else, the faint, clean scent of nascent oxygen. Dotted across this immense, slimy plain are strange, dome-shaped structures. They look like stony mushrooms or giant, rounded cushions, some small and low, others rising to the height of your waist. These are stromatolites, the first large-scale structures built by life. They are not single organisms, but bustling, high-rise cities of cyanobacteria, trillions of single-celled beings working in concert. Each one is a living monument, built layer by painstaking layer over centuries. The bacteria on the surface secrete a sticky mucus to protect themselves from the sun's unfiltered ultraviolet rays. This mucus traps tiny grains of sand and sediment washed in by the tide. As one layer of bacteria is buried, a new one grows on top, reaching for the light, and the cycle repeats. Over immense timescales, the trapped sediment and calcium carbonate secreted by the microbes lithify, turning to stone. You are walking through a forest of living rock, the planet's first reefs, built not by coral, but by the quiet collective toil of bacteria. Look closer at the water swirling around their bases. It is cloudy, not with silt, but with a delicate shimmering effervescence. Countless tiny bubbles are rising from the surfaces of the stromatolites, streaming upwards in silver threads to pop at the surface. This is the great exhalation of a world awakening. The cyanobacteria have perfected a revolutionary kind of alchemy. They have learned to harness the energy of sunlight, to split the atoms of water molecules, and to combine them with carbon dioxide from the air to create sustenance for themselves. It is photosynthesis, the single most important metabolic innovation in the planet's history. And that shimmering cloud of bubbles is its waste product, free oxygen. Homer to the teeming anaerobic life that has dominated the Earth for more than 1 billion years, this gas is a corrosive, deadly poison. For you, it is the breath of life. At this moment, however, the oxygen does not escape into the atmosphere. It has a more immediate fate. The primordial oceans are a pale, strange green, not from life, but from vast quantities of dissolved iron, washed into the seas from volcanic rock and hydrothermal vents over eons. This ferrous iron is soluble in water, and it has saturated the world's oceans. As the cyanobacteria release their tiny bubbles of oxygen, this new, highly reactive gas immediately finds a partner. It seizes upon the dissolved iron, bonding with it in a chemical reaction known as oxidation. The result is iron oxide. Rust. The clear green water is transformed. The newly formed rust is not soluble, and so it precipitates, falling out of the water column like a fine, reddish-brown snow. It settles in a gentle, continuous rain upon the seabed, blanketing the ocean floor in a layer of ochre-colored dust. This process, this slow rusting of an entire planet, continues for hundreds of millions of years. It is a quiet planetary-scale event driven by the photosynthetic work of trillions of microscopic organisms. They are inadvertently cleaning the oceans of iron, one atom at a time, and in doing so, they are creating the greatest iron reserves the world will ever know. The steel in every building, every bridge, every car you have ever seen has its origins here, in this silent, rusty snowfall at the bottom of a 2.5 billion-year-old sea. You walk further along the shore, the squelch of the microbial mat beneath your feet the only sound. In the distance you see cliffs, eroded by wind and time. They are not a uniform colour, but are striped in magnificent horizontal bands of red, black and silver. These are the fossilized remnants of that rusty rain, banded iron formations. Each band tells a story, a rhythm of the ancient world. The rich, red layers of hematite and magnetite are the product of seasonal blooms of cyanobacteria, times when sunlight was plentiful and oxygen production was high, causing a great precipitation of rust. The darker, iron-poor layers of shale and chert represent quieter periods, perhaps winters or times when nutrient cycles shifted and the oxygen output waned. These cliffs are a geological clock, their patient stripes marking the passage of seasons and the slow, pulsating breath of a biosphere in transformation. The world is changing in other ways too. As the cyanobacteria consume carbon dioxide, its concentration in the atmosphere begins to fall. This potent greenhouse gas has kept the planet warm for billions of years, but now its influence is waning. The planet is slowly, imperceptibly beginning to cool. The thick, orange-tinted sky is thinning, becoming a paler, less oppressive version of its former self. A new clarity is entering the world. Wading deeper, you feel the water grow warmer. The stromatolite reefs are even more extensive here, a sprawling, submerged metropolis carpeting the sunlit shallows. And these reefs are not empty. They provide structure, shelter, and a source of food. And in this new, complex environment, a new kind of life is beginning to stir, a quiet revolution taking place in the microscopic realm. Among the simple prokaryotic cells, the bacteria and archaea, something new has appeared. They are eukaryotes, cells like your own. They are larger, more complex, and they possess a radical new organization. Within their cell walls, they have separate compartments, little organelles dedicated to specific tasks. Most importantly, they have a nucleus, a central library that protects their precious genetic code. These new cells did not invent everything themselves. They formed alliances. At some point in the deep past, one such cell engulfed a smaller bacterium capable of processing oxygen for energy. Instead of being digested, the smaller cell survived, finding a safe haven from the increasingly toxic ocean. In return, it shared its surplus energy. This symbiotic partnership was so successful that the guest became a permanent resident, an integral part of the cell, passed down through every generation. It became the mitochondrion, the powerhouse of all complex life. A similar event occurred with a cyanobacterium, which was enfolded into another cell to become a chloroplast, a tiny internal solar panel. This great symbiosis, this act of microscopic cooperation, laid the foundations for all animals, plants, fungi, and protists. These new, complex cells are still invisible to your naked eye, but they are here, swimming through the water with whip-like flagella, hunting and feeding and dividing. And they are experimenting. Some have learned to cling together after dividing, forming simple chains or delicate filaments. It is the first tentative exploration of multicellularity. It is not yet an animal or a plant, but it is a profound beginning, showing that cooperation can build complexity on a whole new scale. You surface from the warm water. The sun is higher now, its glare more intense. There is not yet enough oxygen in the atmosphere to form a protective ozone layer, so the land is blasted with sterilizing ultraviolet radiation. DNA left exposed on the barren, rocky continents would be shredded in moments. Life's dominion is still the sea, where the water itself provides a shield, and here it flourishes. The world belongs to the microbes. The cyanobacteria are at the peak of their power, their stromatolite cities dominating the coastal zones of the globe. They have inherited the earth. But in their success, they have sown the seeds of a world they themselves cannot inhabit. For hundreds of millions of years, the iron in the oceans acted as a chemical buffer, a great sponge that soaked up the oxygen as fast as it was produced. But no sponge can absorb liquid forever. Eventually, the vast reservoir of dissolved iron runs out. The oceans are swept clean of it. The great rusting slows, and then it stops. Now, when the cyanobacteria exhale, their oxygen has nowhere left to go. It begins to accumulate in the water, saturating it, and then it bubbles out, escaping into the air above. For the first time, free oxygen begins to build up in the atmosphere. Slowly, inexorably, the concentration rises from a tiny fraction of a percent towards 1, then 2%. For the anaerobic organisms that have reigned supreme since the dawn of life, this is a catastrophe. Their cellular machinery is not built for this corrosive gas. It rips them apart from the inside out. They are driven into retreat, dying out in the surface waters, and seeking refuge in the deep ocean, in thick sediments, in any dark, forgotten corner of the world where the poison cannot reach them. Their retreat clears the way for the organisms that have learned to tolerate and even thrive on this new gas. The aerobic world, the world of oxygen breathers, is born. You find yourself on a new shoreline. The sand here is different. It is no longer the dark, black sand of volcanic basalt. It is pale, almost white, made of tiny, durable grains of quartz, eroded from the hearts of the first true continents and washed down to the sea by the first river systems. And as you look up, you see the sky beginning to change colour. The hazy, orange-brown atmosphere is slowly clearing. Methane, another powerful greenhouse gas, is being broken down by the new oxygen. What emerges is a sky of faint pale blue. It is not the deep, rich sapphire of the modern Earth, but the world as you know it is beginning to take shape. This transformation, which began around 2.5 billion years ago, is known as the Great Oxidation Event. It was the most profound environmental change in the planet's history, an atmospheric revolution that paved the way for the energetic, complex life that would one day walk the land, swim the seas, and fly through the air. Without this planetary oxygenation, there would be no animals, no trees, no us. But this new world comes at a cost. The destruction of the atmospheric methane, coupled with the ongoing decline in carbon dioxide, has dismantled the planet's greenhouse blanket. The Earth's thermostat is broken. With nothing to trap the sun's warmth, the planet's temperature begins to plummet. Geologically speaking, the cooling is rapid and severe. The revolution you have witnessed is a paradox. The very element that will fuel the fire of complex life is also the one that extinguishes the world's warmth. As the oxygen scrubs the last potent greenhouse gases from the atmosphere, the planet's energy balance is fundamentally altered. The sun's rays still arrive, but now much of their heat radiates straight back into the coldness of space. The air, once thick and hazy, is now thin and clear, offering little insulation against the encroaching chill. This new clarity comes with a stark and growing cold. Standing on that first white beach, under that first pale blue sky, you feel a distinct chill in the air. The gentle lapping of the waves seems more sluggish. A thin, crystalline sheet of ice begins to form over the rock pools near the shore. Then you look up and see something new against the pale cyan canvas. A single, intricate, six-sided crystal of frozen water drifts down, then another and another. The first snowflakes are beginning to fall upon a world that is growing colder by the day, a world on the verge of a deep and profound winter. You are standing on a world made of ice. Not the fractured sea ice of a polar cap, nor the thin, seasonal crust of a frozen lake. This is a planetary glacier, a solid shell of water kilometers thick, entombing an entire world from pole to pole. The ground beneath your feet is a mineral, harder than granite, groaning under its own colossal weight as it slowly, imperceptibly flows. The temperature has plunged to a staggering 50 degrees below 0 Celsius, a cold that surpasses the harshest depths of an Antarctic winter. The air, what little of it has not condensed into frost, is thin and desperately dry, so sharp it would sear your lungs with every breath. A wind, not of furious gales, but of a constant, relentless flow, pours over the endless plains of white. For millennia it has been scouring the ice, carving its surface into vast fields of sastrugi long, parallel ridges of hardened snow, and polishing the frozen water to a dull, milky sheen. The sky is a pale, luminous white, almost indistinguishable from the ground. The horizon is a suggestion, a subtle shift in texture rather than a line. There is no colour here, no comforting blue of a distant ocean or green of a living continent. There is only white on white, an infinite canvas of cold, broken only by the darkest silhouettes of mountain peaks. These are the planet's highest summits, thrusting through the ice sheet like jagged islands of ancient rock in a frozen, silent sea. This is Earth, 700 million years ago. You are witnessing the most profound and severe ice age in its long history, a period so extreme it is known as Snowball Earth. It is a planet pushed to the very brink of life's extinction, a catastrophe that almost sterilized the world. Almost. You begin to walk. Your feet find purchase on a thin dusting of wind-scoured snow, but beneath it lies the ice itself, smooth and treacherous. Without warning, the surface can split open into a crevasse, a deep, vertical wound in the glacier that falls away into absolute darkness, a chasm leading down towards the hidden ocean far below. You move with care, aware that a single misstep on this world would be your last. In the distance, a ridge of fractured ice rises from the plain. This is a pressure ridge, formed where two continental-scale plates of the glacier have collided, their immense, slow-motion force buttling the ice upwards. It forms a wall of shattered, tilted blocks, some the size of buildings, their edges sharp as broken glass. You begin to climb, the brittle ice cracking and shifting under your weight. You must find handholds, pulling yourself up meter by meter over the jagged terrain of a world in deep freeze. From the summit, you gaze out upon a vista of profound stillness. Nothing moves. No bird wheels in the sky, no creature scurries across the ice. The world appears entirely lifeless. Beneath this immense frozen shell, the global ocean is a realm of eternal night. Cut off from the sun's rays, the engine of photosynthesis has stalled. The countless trillions of plankton that once formed the base of the marine food web have vanished. The great reefs of stromatolites, those living monuments built by cyanobacteria over billions of years, are now frozen solid in the shallows, dormant and encased in ice, waiting for a thaw that may never come. The great chain of life has collapsed, yet it has not been entirely broken. Deep below, in the crushing blackness of the abyssal plain, the planet's inner fire still burns. Here, geothermal heat seeps from the crust, keeping the water just above freezing. And around the searing hydrothermal vents, those volcanic fissures in the sea floor, oases of life persist. In the warm, mineral-rich plumes, communities of extremophile bacteria and archaea are clinging on. They are a tiny fraction of the planet's former biosphere, a faint echo of a once thriving world. But they are enough. Life is a stubborn, resilient force. And here, in the deepest, darkest pockets of the frozen planet, it refuses to let go. You descend the ridge and continue your journey across the ice. Days bleed into weeks. The landscape is unchanging, a mesmerizing, hypnotic monotony of ice and sky. The sun, a pale and distant disk, arcs across the heavens, but its light is weak, its warmth negligible. The planet's albedo, its reflectivity, is now almost total. Fresh ice is one of the most reflective natural substances in the universe, and with a world swathed in it, nearly all of the incoming solar energy is simply bounced back into space. This creates a terrifyingly effective feedback loop. The colder the planet gets, the more ice forms. The more ice forms, the more sunlight is reflected, and the more sunlight is reflected, the colder the planet gets. This runaway process, once started, is almost impossible to stop. The trigger for this catastrophe was geological, born from the slow dance of the continents themselves. The vast supercontinent of Rodinia had begun to break apart. As it fractured, it created new coastlines and smaller continents that drifted towards the equator. Here, in the warm, wet tropics, rainfall intensified, and the process of chemical weathering of the newly exposed rock accelerated dramatically. Rainwater, made slightly acidic by atmospheric carbon dioxide, dissolved the silicate rocks, and the resulting chemical compounds washed into the sea, eventually locking that carbon away in carbonate sediments on the ocean floor. Over millions of years, this geological process acted like a giant pump, drawing down the world's most important greenhouse gas, thinning the atmospheric blanket that kept the planet warm. The thermostat was being turned down, degree by degree, until a tipping point was reached. The ice began to spread from the poles, and the albedo effect took over, locking the planet in its white prison. But there is one force the ice cannot suppress, one engine that continues to churn away deep within the Earth: volcanoes. Beneath the frozen surface, the mantle still churns, and magma still pushes its way through the crust. When a volcano erupts, it does so with unimaginable violence, punching through kilometers of solid ice. The superheated lava melts its way upwards in an explosive burst of power, throwing vast columns of ash, steam, and gas high into the thin, frozen atmosphere. You see one now, a dark stain on the distant white horizon. A plume of black ash is rising, spreading out into a vast mushroom cloud that blots out the already dim sun. It takes days of walking to reach it, but as you draw closer, you see a great circular hole in the ice sheet, kilometers wide. It is a caldera, a volcanic crater, but one filled with a substance now rarer than diamonds on this world: liquid water. The lake steams in the frigid air, a stark circle of darkness surrounded by a ring of black volcanic ash and freshly cooled lava. The water is merely warm, just a few degrees above freezing, but in the context of a planet at -50, it is a tropical paradise. And as you look into its dark, steaming waters, you see movement. Not just the simple bacteria of the deep-sea vents, but photosynthetic algae. Microscopic life, thriving in this temporary haven, feeding on the rich volcanic nutrients and harnessing the faint sunlight that filters through the clouds of steam. These volcanic oases are how more complex life survives. They are scattered, temporary refuges in the endless ice, allowing pockets of the old biosphere to weather the long winter. But the volcanoes are providing more than just localized warmth. They are providing the ultimate key to the planet's salvation: carbon dioxide. With every single eruption, anywhere on the planet, vast quantities of CO or We are pumped into the atmosphere. In a normal world, this gas would be dissolved in the oceans and washed out of the air by rain, eventually becoming locked into rock. But on Snowball Earth, the ocean is sealed beneath a cap of ice, and the water cycle of rain and evaporation has all but ceased. There is no efficient mechanism to remove the COEC, so it accumulates. For millions of years, eruption by eruption, the concentration builds, from a few parts per million to a few hundred, then a few thousand. Slowly, inexorably, the greenhouse blanket is being rewoven around the planet. The atmospheric thermostat is being turned back up. The change is imperceptibly slow, but the ice begins to notice. Along the equator, where the sun's rays are most direct, the surface temperature creeps upwards from -50 to -40 to -30. Then, one day, it reaches zero. The ice begins to melt. At first, it is just a sheen of moisture on the surface, a microscopic layer of liquid. But liquid water is much darker than ice. It absorbs sunlight instead of reflecting it. The water warms up, and it melts the ice around it, creating a larger patch of water, which absorbs even more sunlight. The feedback loop that froze the world begins to run in reverse. You are standing on the equatorial ice when the great thaw begins. It starts with a sound like a rifle shot, a sharp crack that echoes for miles across the silent plain. A fracture appears in the ice at your feet, widening as you watch, racing away towards both horizons. From the crack, dark ocean water wells up, cold and still, but liquid. The sleeping ocean is beginning to stir. The melt is not a gentle process. It takes millennia, but once it gains momentum, it is an unstoppable, cataclysmic event. The cracks spread into a planetary network. Melt pools grow into vast lakes. Rivers of meltwater, wider than any that exist today, carve deep canyons into the ice as they rage towards the sea. Continent-sized bergs carve from the retreating glaciers, creating an ocean choked with colossal icebergs. As the ice finally pulls back, the land is revealed for the first time in millions of years. It is a surface scoured clean, scraped down to the bedrock by the unimaginable weight of the moving glaciers. There is no soil, no trace of vegetation, just sterile stone, polished and scarred by its long entombment. The world is a blank slate, reset to its geological foundations. You stand on that bare rock, feeling the warmth of the sun in a sky now thick with carbon dioxide. The atmosphere is dense, the greenhouse effect in full force. The planet has swung violently from one extreme to the other, from a global snowball to a global hothouse. The long winter is over, and an intense planet-wide summer has begun. The ocean, now free, roars back to life. The acid rain falling from the CO2-rich sky weathers the newly exposed rock, washing a torrent of minerals and nutrients into the sea. This planetary-scale fertilization event triggers a biological explosion. Cyanobacteria bloom in numbers beyond comprehension, turning the oceans a cloudy green. Their frenzied photosynthesis pumps enormous quantities of a waste gas into the sea and the sky, oxygen. The warmer, nutrient-rich world is also becoming more oxygenated. In the shallow seas, conditions are gathering for something entirely new. You wade into the water, and you see them. Strange, soft-bodied organisms quilting the seafloor. These are not bacteria or algae. They are animals. The first large animals to ever exist. They are simple, alien forms, some like flattened, segmented discs, others like fronds, anchored to the seabed. They have no heads, no mouths, no guts. They seem to absorb nutrients directly from the water around them. For 3 billion years, life was a world of the very small. Now, in the aftermath of the Great Freeze, it is experimenting with size, with complexity, with multicellular cooperation on a scale never seen before. This is the Ediacaran biota, an early experiment in large animal life. Bizarre, fleshy structures occupy a world with few, if any, predators. The conditions that allowed these creatures to arise will also support another evolutionary expansion. Skeletons, shells, complex eyes, and active predation lie ahead. The largely static communities of the Ediacaran seafloor will give way to a world of movement. You are floating in a warm, primordial sea. Sunlight passes through clear water and dapples the seafloor 100 feet below. The atmosphere now contains enough oxygen to support more active ecosystems. This is the Cambrian Period, some 540 million years ago. Beneath you, soft sand lies in ripples among algae and strange anchored creatures. For 3 billion years, most life was microscopic. Now ecological relationships are changing. Animals have mouths, senses, and the ability to pursue one another. Eating and avoiding being eaten will reshape life in ways the earlier microbial world never experienced. You watch as a creature, about the size of your hand, scuttles across the sand with a newfound purpose. It is an arthropod, one of the very first. Its body a series of articulated segments encased in a tough, flexible exoskeleton. Its compound eyes, perched on mobile stalks, scan the world in a mosaic of light and shadow, and a tail like that of a shrimp provides balance and propulsion. It is hunting. Its sensory appendages, delicate and feathery, probe the soft sediment, tasting the water for the chemical traces of hidden life. It is searching for worms, for smaller, softer creatures, for anything it can overpower. When its senses lock onto a burrowing worm, the interaction is swift, efficient, and utterly new. The predator-prey relationship, the great engine of evolutionary change, has been ignited, and now the prey must respond. In this new and dangerous world, to be soft and slow is to be a meal. So, in response, life begins to innovate. Worms burrow deeper, developing complex tunnel systems. Other creatures begin to secrete minerals, drawing calcium carbonate from the seawater to build the very first shells. Some evolve sharp, defensive spines, turning their bodies into unappetizing fortresses. A great evolutionary arms race has begun, playing out across the sunlit sea floors of the globe, and it is driving biological creativity at a pace the planet has never witnessed. Within a geological blink of an eye, a mere 10 or 20 million years, the oceans are teeming with a bewildering diversity of experimental body plans. You drift through this Cambrian seascape, a silent observer in a world of biological wonders. You pass creatures like Wewaxiac, a slug-like animal covered in a coat of mail made from scales and long, elegant spines. You see Hallucigenia, aptly named, walking on stilt-like legs with a row of defensive spikes along its back. And there, a creature with 5 eyes on stalks and a long, flexible proboscis ending in a grasping claw. This is Opabinyah, an animal so strange that when its fossil was first presented at a scientific conference, the audience laughed, assuming it was a joke. Here, evolution is throwing everything at the wall to see what sticks. You swim on, through a tranquil forest of sponges. They stand tall and vase-shaped, their simple bodies perfectly designed for a life of filter feeding, tirelessly pumping water through their pores to extract the ocean's thin soup of nutrients. Around their bases, smaller animals graze on mats of algae. You recognize the first mollusks, the ancestors of snails and clams. Their shells are simple cones, unadorned and functional, but they are armor nonetheless, a sufficient deterrent for many of the new predators. It is a medieval world in miniature where survival depends on the strength of your castle walls. In the distance, a larger form resolves itself from the blue haze. You swim towards it, your curiosity piqued. The creature is immense by Cambrian standards, perhaps 2 feet long, maybe even more. It is Anomalocaris, the abnormal shrimp, and it is the undisputed apex predator of this age. It moves with a strange grace, its long, segmented body undulating as 2 rows of flexible lobes ripple along its flanks, propelling it through the water. At the front of its body are 2 large, spiny appendages, used for grasping prey and bringing it towards a mouth unlike any other. It is a circular plate of sharp, chitinous sections that open and close like the aperture of a camera, helping it grasp and process its prey. But its most revolutionary feature is its pair of enormous compound eyes. Each eye is composed of thousands of individual lenses, a colossal number for this early stage of life, granting it some of the most acute vision the world has yet seen. And vision changes everything. The ocean is no longer just a collection of chemical gradients and vibrations to be sensed. It is a visual landscape, a 3-dimensional space of light, shadow, and movement. Prey can be spotted from a distance. Predators can be avoided. The evolutionary pressure to see, and to avoid being seen, intensifies across every branch of this new animal kingdom. You watch as the Anomalocaris hunts. It moves with a slow, deliberate patience, its great eyes scanning the seafloor below. It is stalking a trilobite, a heavily armored arthropod that is methodically grazing on a patch of algae, oblivious to the shadow passing over it. The trilobite's body, divided into its characteristic 3 lobes, flexes as it moves along the sand. The Anomalocaris descends, silent and purposeful, closer and closer. Then, with a sudden burst of speed from its swimming lobes, it closes the final distance and seizes the trilobite in its grasping appendages. The trilobite's defense is immediate and instinctual. It curls into a tight, dense ball, presenting a solid wall of calcified exoskeleton to its attacker. The mouthparts of the Anomalocaris are powerful, but they struggle to find purchase on the smooth, hard armor. The predator does not give up. It manipulates the curled trilobite, turning it over and over, probing for a weak point. Eventually, it finds one, the softer, less protected underside. The sharp plates of its mouth press in, and the trilobite's defense is breached. It uncurls in a futile attempt to escape, but it is too late. This is the new logic of nature, a world of specialized tools for attack and defense, playing out a dance that will continue for all of time. You drift away from the aftermath of the hunt and explore a nearby reef. It is not a coral reef. Corals are still many millions of years in the future. This reef is a more ancient construction, built by strange, cup-shaped organisms called archaeocyathans, sponge-like animals that formed the world's first large-scale reefs, aided by calcified algae that helped bind the structure together. It is a bustling, complex metropolis, the first true ecosystem. Here, in the countless crevices and hollows, dozens of different species interact, competing for space and food, or finding shelter from the dangers of the open sea floor. Complexity is being piled upon complexity. In a small, sheltered crevice, you notice a cluster of tiny translucent eggs suspended in a protective jelly-like matrix. They are being guarded by a small arthropod, which waves its appendages defensively at any creature that ventures too close. This is a profound development, parental care. For the first time, an animal is not just scattering its eggs to the currents, but is actively investing time and energy in protecting its offspring. It is a simple, instinctual behavior, but it is a hint of the sophisticated strategies and social structures that will one day emerge. You ascend, rising through the warm water column towards the light. As you break the surface, you are greeted by a sky that is a deep, familiar blue. After billions of years of microbial activity, atmospheric oxygen is rising. The reconstructions differ over its precise level, and many place it substantially below the air you breathe today. High above, an ozone layer filters much of the sun's harshest ultraviolet radiation. You wade towards the shore. The beach is not sand, but a collection of smooth, wave-worn cobbles and boulders. Beyond it, the land is a silent, empty vista of grey and brown. It is utterly barren. There are no plants, trees, soil, or grass. There is only rock, dust, and the sound of wind and waves. The Cambrian explosion was an overwhelmingly marine revolution. The widespread colonization of the continents will have to wait. But here in the ocean, the revolution is complete. In this relatively short span of time, almost every major animal phylum that exists today has made its first appearance in the fossil record. The ancestors of insects and crustaceans, the arthropods. The ancestors of snails and squid, the mollusks. The ancestors of starfish and sea urchins, the echinoderms. And among them, swimming nervously in the sunlit shallows, is a small, unassuming creature. It is slender and eel-like, and it propels itself with a sideways flick of its body. It has no jaws, no limbs, and no true bones. But running down its back is a flexible rod of cartilage called a notochord. It is a primitive spine. This is a chordate, a member of the phylum that will eventually give rise to all fish, amphibians, reptiles, birds, and mammals. This is your distant ancestor. It is not much to look at, but that simple nerve cord running along its back is the key to everything that comes next. It is the beginning of a centralized nervous system, a brain in its most embryonic form. Over the next 500 million years, that simple structure will grow, fold, and complexify, eventually, and perhaps improbably, giving rise to consciousness. For now, though, that future is unimaginable. Arthropods are among the most conspicuous animals in the Cambrian oceans. Trilobites patrol the seafloor while Anomalocaris cruises above them. Far below, hydrothermal vents continue to release superheated, mineral-rich water from the planet's interior. The fossil record does not reveal a modern-style vent community here, and the giant red-plumed tube worms familiar from today belong to a much later branch of the animal tree. What these Cambrian vents certainly offer is chemical energy for microbes, maintaining an old, sunless ecosystem beneath the changing world above. You drift for a while longer in this ancient sea, a silent observer in a world teeming with novelty. The water is a hazy, sun-dappled soup of algae and microscopic life, food for countless filter feeders that have anchored themselves to the seabed. Above them, strange arthropods with their jointed limbs and hard exoskeletons scuttle and swim, exploring every available niche. They are the new masters of this realm, a testament to the power of a successful body plan. Their segmented bodies and specialized appendages will allow their descendants to conquer not just the oceans, but the land and the air as well. For now, though, this is their entire world. You watch as a trilobite curls into a defensive ball, its armored shell protecting it from harm. The ocean is now shaped by predators, prey, and new ways of sensing and responding. You ascend slowly, returning to the light and warmth of the surface. As you break through the shimmering meniscus one last time, you take a symbolic breath of the clean, oxygen-rich air. The planet has found a new kind of equilibrium. The great global ice ages of the past are over. The atmosphere is stable and protective, and life, in all its bewildering new forms, is not just surviving, but thriving. The foundations have been laid. The blueprints for the animal world have been drafted and tested. But the story of a living planet is one of constant, quiet transformation. Stability is only ever a temporary state in the Earth's long and restless journey, and the chapters to come will hold changes as profound as those you have just witnessed. You are standing at the edge of what was once a forest. The trees are all dead. Not recently, but long ago. They are charred, skeletal remains, toppled and broken. A silent graveyard of giant club mosses and sprawling seed ferns, their fossil-like trunks lie tangled like colossal spilicans, all coated in a fine grey powder of ancient ash. There is no birdsong, no rustle of life in the undergrowth. There is only a profound and heavy silence. The sky above is a uniform, oppressive ceiling of rust. Hues of orange, red and brown bleed into one another, a vast watercolour wash of atmospheric distress. A volcanic haze hangs so thick and low that you cannot see the sun, not even as a disk. There is only a dim, diffused glow somewhere overhead, a faint memory of daylight struggling to penetrate the murk. The air itself is a presence, thick and acrid, carrying the taste of sulphur and other volcanic poisons. It is an atmosphere no longer meant for the life that evolved within it, a chemical soup hostile to lungs and gills alike. This is the Earth as it was 252 million years ago, at the boundary between the Permian and Triassic periods. You are a silent witness to the most severe extinction event in the planet's history, an episode of planetary trauma so profound it is simply called the Great Dying. In what amounts to a geological instant, a span of perhaps 60,000 years, the vast majority of life was extinguished. Up to 95% of all marine species and 70% of terrestrial vertebrate species vanished forever. It was not a gradual decline, but a swift and brutal reaping. The ground beneath your feet is unnaturally warm, not the pleasant warmth of a sun-baked path, but a deep geothermal heat that radiates up from the planet's core. It seeps through the soles of your shoes, baking the air from below, turning this desolate landscape into a planetary-scale convection oven. And in the distance, through the shimmering haze, you can see the reason for this impossible heat. Lava. This is less like the cone-shaped eruption of a single volcano, and more like a vast flood of basalt pouring from immense fissures in the Earth's crust. These are the Siberian Traps, the largest known volcanic event of the last half-billion years. Across roughly 1 million years, repeated outpourings of molten rock will cover an area larger than Western Europe and bury the land under kilometers of black basalt. You walk towards the source of the glow, the air growing hotter with every step. The ashen ground crunches underfoot, and you notice fine cracks spreading from your weight, as if the very earth has become brittle. And then you see it, the flow front. A creeping wall of molten rock, perhaps a few meters high, advances at a slow walking pace. It is utterly inexorable, a liquid tide of planetary interior consuming everything in its path. The dead trees that still stand burst into flame long before the lava reaches them. The radiant heat alone is enough to ignite their dry, petrified wood from many meters away. The lava itself is a mesmerizing, terrible river of orange, red, and yellow, its surface cooling into a dark, cracking skin that reveals the incandescent liquid beneath. The sound it makes is not a roar, but a deep, grinding rumble, a constant, low-frequency tremor you feel in your bones. This is punctuated by the sharp, cracking sounds of the cooling crust, a sound like shattering glass on a colossal scale. You step back, finding a vantage point to watch the slow, relentless advance. The lava meets the bed of a dried-up river and spills into it, instantly vaporizing any residual moisture trapped in the silt. A great plume of steam and toxic gas hisses violently, rising to join the permanent, poisonous haze in the sky. Where a river once carved a path of life through the landscape, there is now only a new formation of black, glassy rock, its edges still glowing with trapped heat. And this is just one flow, on one day, in one small part of a continent. This process is being repeated by hundreds, then thousands of similar flows, spread across millions of square kilometers, continuing almost without pause for 1 million years. With every cubic kilometer of lava comes an immense volume of gas, injected directly into the atmosphere. Carbon dioxide, sulfur dioxide, methane, and chlorine flood the air, wrapping the Earth in an ever-thickening blanket. This blanket traps the sun's heat, triggering a runaway greenhouse effect that will change the world forever. The global temperature begins to climb, 5 degrees Celsius, then 10, perhaps as much as 15 degrees warmer than it was before the eruptions began. The polar ice caps, which had persisted for millions of years, melt away entirely. The sea level rises, flooding the low-lying coastal plains and drowning entire ecosystems. But the warming of the air is only the beginning. The true catastrophe is unfolding in the world's oceans. You find yourself transported to a coastline. The beach is not sand, but a dark mixture of volcanic ash and mud littered with the dead and the dying. The shells of ammonites, their beautiful spiral forms inert and empty, are washed about in the sluggish surf. Trilobites, those ancient, armored navigators of the Paleozoic seas, lie half-buried and still. Countless fish and brachiopods form pale, rotting drifts at the high tide line, their bodies filling the already sulphurous air with the thick, cloying stench of decay. The water itself is a sickly, murky green, not the vibrant green of healthy plankton, but the disturbing color of anoxia. The ocean has been starved of oxygen. The immense volume of carbon dioxide in the atmosphere has been dissolving into the seawater, creating carbonic acid. This has raised the ocean's acidity to a point where creatures can no longer form shells or skeletons from calcium carbonate. The very water has become corrosive to the life within it. Without oxygen, the deep ocean has stagnated. In these suffocating depths, anaerobic bacteria have flourished. These microbes, which thrive in oxygen-free conditions, produce a toxic waste product, hydrogen sulfide. This poisonous gas, with its signature smell of rotten eggs, begins to saturate the deep water, turning it into a toxic layer. As the world warms, the great ocean currents that circulate oxygen and heat around the globe slow down, and then they stop. The ocean becomes stratified, layered like a poisoned cake. At the surface, the water is unnaturally warm and acidic with little oxygen. The depths have become a cold, anoxic tomb, rich in hydrogen sulfide. And slowly, catastrophically, this deep, poisonous water begins to rise, poisoning the shallows from below. You wade into the tepid water. It is as warm as a bath, a deeply unnatural temperature for an open sea. The lack of a temperature gradient between the equator and the poles has stilled the planet's circulatory system. A lone fish swims sluggishly past your leg. Its movements are weak, its gills inflamed as it struggles to extract what little oxygen remains from the water. It gives a final, feeble flick of its tail, then drifts to the surface, turning belly up to join the silent, floating armada of the dead. This is what the end of a world looks like. Not a sudden, fiery impact from the heavens, but a slow, suffocating fever from within. Leaving the dead ocean behind, you move back across the land. The landscape is one of universal ruin. The soil is baked hard, cracked into deep, geometric patterns. The great river systems have been reduced to dusty channels, occasionally scoured by violent, acidic flash floods during the brief, torrential rainstorms that sweep across the continent. The once vast forests are gone, replaced by sprawling badlands of eroded gullies and sterile plains. Yet, even here, there is movement. In the distance, a small herd of strange-looking animals plods across the wasteland. They are Lystrosaurus, a type of synapsid, the group of animals that includes the ancestors of mammals. With their barrel-chested bodies, beaked faces, and two small tusks, they look like a cross between a pig and a lizard. They are among the few land vertebrates to survive the extinction in any great number. They are hardy, adaptable, and perhaps they were burrowers, able to shelter from the worst of the heat and toxic air. They are emaciated, desperately searching for any remaining roots or tough vegetation in a world where almost nothing grows. Most will not make it, but a few will, just enough to carry their lineage forward, a tiny flicker of life in the overwhelming darkness. The great food chains have collapsed. The apex predators are gone. The vast herds of herbivores are gone. The lush forests that fed them are gone. In this shattered ecosystem, the only true winners are the fungi, the bacteria, and the decomposers. They feast on the endless supply of the dead, thriving in the chaos, breaking down the complex machinery of life into its simplest components, recycling the nutrients, and unknowingly preparing the ground for whatever comes next. You climb a low hill and look out. From horizon to horizon, the view is the same. A scorched earth under a poisoned sky, bordered by a dying ocean. The planet is profoundly wounded, but it is not dead. Deep underground, in burrows, other small creatures persist. Insects, worms, and the hardiest of reptiles wait out the apocalypse. In the soil, dormant seeds hold the genetic memory of a greener world, waiting for rain that is not acid. And even in the oceans, in a few isolated pockets and refugees, a handful of species cling to a precarious existence. They are all waiting for the eruptions to cease, waiting for the skies to clear, waiting for the planet to begin the slow, arduous process of healing itself. You feel the first stirrings of this change in the air, a subtle shift in the wind. And it will heal. Over millions of years, the great lava fields of the Siberian traps will cool and fall silent. The excess carbon dioxide will be slowly drawn out of the atmosphere, absorbed by the rock and the recovering ocean. The planet's temperature will gradually fall. The oxygen levels will begin to rise. The rains will lose their acidic bite, and into this quiet, empty world, new forms of life will tentatively step, finding a planet remade, a stage cleared for a new and spectacular dynasty. The few survivors of the Great Dying will inherit a world of opportunity, an open frontier for evolution to fill with new and wonderful forms. You are standing in a world of deep, profound green, a jungle from a time before the word existed. The air is a presence, something you feel on your skin and in your lungs. It is thick, heavy, and so saturated with moisture that each breath feels like a slow drink of warm water. The heat is immense, a damp, clinging blanket in the high 30s Celsius, and it is utterly still. No breeze stirs the giant leaves. There is only this weighty, humid air, alive with the incessant orchestral hum of insects. The trees that surround you are giants from an earlier age of the world. Towering conifers, ancient relatives of monkey puzzle trees, their trunks rising 20, 30, even 40 meters before the first dense branches spread out to form a near unbroken canopy. Sunlight struggles to pierce this ceiling of green, and where it succeeds, it falls in dusty golden shafts, illuminating a world that knows almost no other color. The forest floor is a sea of ferns, some waist high, others taller than you, their delicate fronds dripping with condensation. They carpet everything, broken only by the moss-covered husks of fallen trees and the stout, armored trunks of cycads, each crowned with a stiff rosette of palm-like leaves. There are no flowers here. The grand botanical revolution of petals and nectar is still many millions of years in the future. This is a monochromatic world, a symphony played in 1,000 shades of green and brown. And it is loud. The air vibrates with a sound so constant it almost becomes silence. It is the sound of millions of insects, the high-pitched rhythmic drone of cicada-like creatures, the clicking and whirring of beetles, and the deep resonant buzz of dragonflies with the wingspans of small birds. You instinctively duck as one of these aerial predators swoops past, its vast, iridescent compound eyes catching the light, its powerful mandibles open as it hunts smaller flying things. Everything is wet to the touch. The ferns leave streaks of moisture on your arms as you push through them. A fine mist hangs in the air, a product of the forest's own breathing, mingling with the exhalations of a wide, slow river you can hear somewhere ahead. Then, another sound cuts through the insectile chorus, a sound so deep and powerful it makes the ground beneath your feet tremble. It is a bellow, a resonant, chest-rattling call that seems to come from the heart of the forest itself. You stop, every sense alert, listening to the profound silence that follows. It comes again, closer this time, accompanied by the heavy crack of breaking branches, and then, through a gap in the colossal trees, you see it. A dinosaur. Not one of the small, skittish creatures of the early Triassic, but a true titan of the Jurassic. A sauropod. It moves with a slow, ponderous grace, a living mountain of flesh and bone. Its head, perched atop a neck of impossible length, seems comically small for its body, swaying gently as it browses from the high canopy. Its body is a vast, barrel-shaped vessel, supported by 4 pillar-like legs that plant themselves with geological certainty. A tail, even longer than its neck, trails behind, carving a broad furrow through the ferns. You watch, mesmerized, as it feeds. The long neck arcs upwards, the simple, peg-like teeth at the end stripping needles from a high branch. It doesn't chew. The motion is ruthlessly efficient, pluck, strip, and swallow. You can almost trace the path of the woody material as it begins its long journey down that incredible neck, destined for a gizzard-like stomach where grinding stones, or gastroliths, will do the work of molars. This creature is a biological machine, engineered for the sole purpose of converting vast quantities of tough plant matter into energy. You soon realize it is not alone. Through the trees, you see others, a herd. Perhaps 10 or 20 of these giants spread throughout this small patch of forest. They are moving together, a slow-motion river of life, methodically stripping the vegetation. They are not silent creatures. They communicate with low, rumbling calls, many of which are so deep they fall below the range of your hearing. You feel this infrasound more than you hear it, a gentle vibration in your chest, a form of communication that can travel for miles through the dense forest, keeping the herd together, warning of danger, and connecting parent to offspring. You follow them at a respectful distance. The ground shudders softly with their combined weight, reminding you that these are among the largest land animals ever to walk the earth. Their scale rests on an unusual combination of anatomy and ecology: air-filled bones, efficient lungs, long necks, rapid growth, and landscapes capable of supplying enormous quantities of vegetation. The herd arrives at the bank of the river you heard earlier. It is wide and sluggish, its water the colour of tea, heavy with sediment and tannins from the forest. The giants wade in without the slightest hesitation, the water rising to their bellies. They lower their long necks to drink, siphoning up hundreds of litres of water to fuel their colossal metabolisms. They are furnaces, constantly burning through fuel, constantly needing to replenish their stores of food and water. As they drink, a flicker of movement on the opposite bank catches your eye. Something is low to the ground, moving with a patient, deliberate stealth that contrasts sharply with the ponderous certainty of the sauropods. You see a large head first, powerfully built, its jaws lined with teeth like serrated daggers. Then the body emerges from the ferns. It is a bipedal predator, its weight perfectly balanced over two muscular hind legs by a long, stiff tail. Its arms are surprisingly small, yet tipped with viciously hooked claws. It is an Allosaurus, a great hunter of the Jurassic. It is watching the herd. Its gaze is fixed, intelligent, scanning for any sign of weakness, an individual that is old or sick, or a juvenile that has strayed too far from its mother. But the herd is not oblivious. The low rumbles change in tone. The great animals have seen the predator. The adults slowly begin to shift their positions, forming a protective circle around the younger members in the centre. Their immense tails, which normally drag on the ground, are now held aloft, ready to be swung like devastating bullwhips. The Allosaurus continues to pace the far bank, a picture of lethal patience. It weighs its chances, measures the risk against the potential reward, and, apparently deciding the formidable defence is too much to overcome, it melts back into the shadows of the forest. The hunt is over before it began. You find a place to cross the warm, shallow river. You feel the gentle brush of unseen things against your legs, ancient forms of fish, perhaps a large amphibian seeking refuge in the mud. A few meters away, the ridged back and watchful eyes of a crocodilomorph break the surface. It observes you with an unnerving stillness, an intelligence honed by survival across eons. Its kind are ancient, having endured the great dying that ended the Permian period. They are masters of their niche, so perfectly adapted that their basic form will carry them through the age of dinosaurs and far, far beyond. On the other side of the river, the dense jungle gives way to a more open floodplain. Here, the sheer diversity of reptilian life is laid bare. You see herds of smaller dinosaurs, ornithischians, the bird-hipped herbivores. There are stegosaurs, their backs adorned with a double row of imposing plates, their tails tipped with defensive spikes, methodically cropping low-growing ferns with their beaked mouths. Smaller, bipedal dinosaurs move in nimble flocks, their heads constantly jerking up, scanning the sky and the tree line for danger. The sky itself is another realm, ruled not by birds, but by pterosaurs. These are not dinosaurs, but a separate branch of the reptile family tree that conquered the air. They soar on vast, membranous wings, a skin membrane stretched over a single, dramatically elongated finger. Some are the size of gulls. Others have wingspans that rival a small aeroplane. They glide effortlessly on thermal updrafts, their sharp eyes scanning the plains below for fish in the river or the carcass of a less fortunate creature. You sit on a fallen log, a silent observer in this lost world. This peaceful afternoon on a Jurassic floodplain offers a glimpse of an age that will endure for an astonishing span of time. For 150 million years, from the Triassic through this Jurassic period and into the Cretaceous to come, the dinosaurs will be the undisputed masters of the planet. They will diversify into thousands of forms, filling every conceivable ecological niche on land. They will be predators and prey, browsers and grazers, swimmers and perhaps even burrowers. They will grow to the size of buildings and shrink to the size of chickens. They will develop intricate social behaviors, vibrant crests and, in one revolutionary lineage, feathers. This world feels eternal, unshakable. And yet its balance will be broken far in the future, in a single day. That day is still more than 60 million years away. For now, the world belongs to them. The climate is warmer, and the air holds far more carbon dioxide than in your own time. Estimates of Jurassic oxygen vary between models, so there is no honest single percentage to give you. What is clear is that thick vegetation supports immense active animals across the land. You stand and walk towards a quieter part of the clearing. You hear a sound that is different from the grunts and bellows of the larger animals. It is a soft, gentle cooing, almost bird-like. Drawn by the sound, you move towards a dense thicket of cycads. There, concealed from casual view, is a nest, carefully constructed from twigs, leaves and mud. Inside are several large oblong eggs, and sitting carefully upon them, guarding them with an attentive posture, is a small theropod dinosaur. It is covered not in scales, but in a coat of fine, downy feathers, with longer, more complex feathers on its arms and tail. They are patterned in subtle shades of brown and grey, providing perfect camouflage. This is the link, the quiet, profound connection between these reptilian giants and the birds of our own time. This small, feathered creature, brooding on its nest, displays a parental care that hints at the warm-blooded future of its lineage. It does not know, of course, that its descendants will be the sole survivors of their kind, that they will outlive the Titans and inherit the sky. Evolution has no foresight, it simply is. The small creature turns its head, its bright, intelligent eyes regarding you for a moment without fear. It seems to understand you are no threat. The air is still, holding the quiet intimacy of the scene. You can almost feel the warmth radiating from the nest, a testament to the high-energy metabolism that fuels this small, feathered body. This creature is a warm-blooded whisper of the future, nestled here in the deep past. For now, this small dinosaur is just a parent, keeping its future generation warm and safe. You watch for a moment, a witness to this tender scene from a forgotten time, and then you leave it in peace. The deep forest begins to close in around you once more, the air growing heavy again with the scent of damp earth and crushed ferns. You walk on, through the deep green of the Jurassic, moving quietly forward through time, towards the final, most spectacular chapter in the long Age of Reptiles. You are floating in the silent theatre of space, a quiet observer high above the Earth. Below you, the planet turns on its axis with a slow, hypnotic grace. It is a world of impossible vibrancy, a living jewel of blue, green and swirling white. You see the familiar shapes of continents, yet they are subtly estranged from the maps of your own time. A great, shallow seaway runs down the centre of North America, a turquoise ribbon dividing the land. Europe is not a solid landmass, but a scattered archipelago of large islands basking in a warm tropical sun. And there, to the south, the island of India continues its lonely million-year journey northwards, still far from its eventual mountain-building collision with the Asian plate. This is the late Cretaceous period, a world basking in the peak of a long greenhouse climate. The air is warm and moist, and life has responded with an abundance that is almost overwhelming. Great herds of dinosaurs move like living mountains across the plains, their calls echoing through forests of ferns and flowering trees. In the skies, pterosaurs with colossal wingspans glide on thermal updrafts, their sharp eyes scanning the lands and seas below. The oceans themselves are a teeming metropolis of life, home to coiled-shelled ammonites that drift like ornate chandeliers and immense marine reptiles, the mosasaurs, that patrol the depths. Life is not just thriving, it is exuberant. The planet has reached a crescendo of biological diversity. And then, against the infinite black tapestry of space, you notice something. A single point of light, moving with a purpose and a speed that sets it apart from the distant, wandering comets or the fixed, glittering stars. It grows steadily brighter, its trajectory unwavering. As it resolves from a point into a shape, you begin to comprehend what you are witnessing. It is not a visitor, it is an arrival. This is an asteroid, a colossal fragment of the early solar system. It measures almost 10 kilometers across, a jagged, tumbling mountain of rock and iron, dark and ancient. For millions of years, it has followed a lonely path, nudged from its stable home in the asteroid belt between Mars and Jupiter. A subtle gravitational pull, a planetary alignment, has gently altered its orbit, sending it on a long, elliptical journey that was always destined to intersect with the path of the Earth. And today, on this otherwise unremarkable day in the late Cretaceous, those two paths finally cross. You watch as it begins its final descent, meeting the thin outer tendrils of Earth's atmosphere. A silent, incandescent friction begins to build, transforming the asteroid's immense kinetic energy into pure heat. The air in its path, unable to move aside quickly enough, compresses into a sheath of plasma hotter than the surface of the sun. The very atmosphere ignites, forming a brilliant, expanding shockwave that races ahead of the rock itself. From the ground, for any creature that happened to look up, it would appear as though a new sun had been born in the sky, a light more brilliant and more terrifying than anything ever witnessed. For a few silent, searing moments, it would outshine the true sun, erasing every shadow from the face of the land. Then, less than a second later, the asteroid makes contact. Its destination is a shallow tropical sea, covering what will one day be called the Yucatan Peninsula in Mexico. The impact is not a collision in any familiar sense. The asteroid crosses the warm water, which flashes into steam and penetrates the limestone seabed before driving into the crust. In that instant, its kinetic energy passes into the planet. The explosion is a flash of pure white energy. The asteroid and the rocket strikes are not melted, but vaporized, turned into an expanding bubble of superheated plasma. A crater begins to form, not by the slow grinding of geology, but in a matter of seconds. It is a wound in the Earth's crust, 30 kilometers deep and more than 180 kilometers wide. The floor of this new crater, under unimaginable pressure, rebounds upwards higher than Mount Everest before collapsing back down, creating a series of concentric rings, like the ripples from a stone dropped in a pond, but frozen forever in rock. From this point of impact, a shock wave radiates outwards in all directions. It is not merely a wave of pressure, but a moving wall of absolute destruction. It travels faster than the speed of sound, scouring the landscape clean. Forests, hills, and any living thing in its path are simply obliterated, erased down to the bedrock. Within minutes, an area the size of a large country is transformed into a silent, smoking landscape. Simultaneously, the force of the impact hurls trillions of tons of pulverized and molten rock upwards. This is the ejector. Some of it is thrown with such violence that it achieves escape velocity, leaving Earth's gravitational pull forever to drift through the solar system. Most of it, however, is blasted high above the atmosphere, on long, arching, suborbital trajectories. You watch from your vantage point in space as this glowing cloud of debris expands, spreading out from the impact site like a ghastly flower, preparing to rain back down upon the entire planet. This returning ejector is not a gentle shower of dust. It is a storm of superheated particles, from grains of sand to boulders the size of houses. As these fragments re-enter the atmosphere all around the globe, they glow with intense heat, like a meteor shower of impossible density. The sky, for a time, is filled with billions of shooting stars. The combined thermal radiation from this planetary firestorm is immense, heating the upper atmosphere to the temperature of an oven. This intense pulse of heat is enough to cause dry leaves, ferns, and forests to spontaneously combust, not in one place, but everywhere, all at once. Within an hour of the impact, continent-spanning wildfires ignite across the globe. You descend now, through the thickening haze, through the clouds of smoke and ash. The sky is no longer blue, but a bruised, impenetrable black. Though it is midday, the world is cast into a darkness deeper than any night, a darkness lit only by the hellish orange flicker of the global fires that stretch from one horizon to the other. On the ground, the devastation is profound. The great forests are now pillars of flame. The air itself is a toxic brew of smoke, ash, and chemical compounds released from the vaporized rock, including vast quantities of sulfur. The initial, searing heat pulse has baked the surface of the Earth, and now the suffocating atmosphere is completing the devastation. You come across a hadrosaur, one of the great duck-billed dinosaurs, lying on its side by a dried-up riverbed. It bears no mark of violence, no burns or crushing injuries. It is simply still. Like countless others, it survived the initial blast only to be defeated by the air itself, its powerful lungs clogged with a slurry of hot ash. The ground is a testament to the suddenness of the event. It is littered with the bodies of dinosaurs, pterosaurs, birds, and small mammals. The sky has fallen, and it has taken almost everyone with it. The great fires burn for months, consuming the oxygen-rich atmosphere and the planet's vast forests, turning entire continents into landscapes of charcoal and ash. As the last of the fires die down, their legacy rises. Billions of tons of fine soot and dust, lifted by the heat of the impact and the infernos, are carried high into the stratosphere. There, they are joined by sulfate aerosols, formed from the sulfur-rich limestone that was vaporized at the impact site. This veil of debris spreads around the planet, wrapping it in a thick, impenetrable shroud that blocks the light of the sun. The impact winter begins. Without the sun's warmth, global temperatures plummet. In the space of weeks, the average temperature drops by more than 20 degrees Celsius. The warm, temperate world of the Cretaceous is plunged into a deep and bitter cold. Snow begins to fall in the tropics. The oceans, which hold their heat for longer, steam in the frigid air, creating hyper-hurricanes and storms of a scale and violence the Earth has not seen before or since. You find yourself standing on a desolate beach. The sea is a dull, lifeless grey, and the waves that lap the shore are thick and sluggish with suspended ash. The surface is dotted with the dead. The beautiful, coiled shells of ammonites float beside the bodies of plesiosaurs and the mighty mosasaurs. The entire marine ecosystem has collapsed from the bottom up. The phytoplankton, the microscopic plants that form the base of the ocean's food chain, require sunlight to survive. In the deep, unending darkness of the impact winter, they have perished, and with them, everything that depended upon them. On land, it is the same story. Without sunlight, photosynthesis has ceased. The plants wither and die. The great herbivorous dinosaurs, deprived of their food, starve, and the carnivores, with nothing left to hunt, soon follow. The world falls silent. Yet life is tenacious. You find a small burrow dug into the cold, ashen soil. Inside, a small, furry, shrew-like mammal is curled up with its young. It is warm-blooded, its fur providing insulation against the cold. It is small enough to survive on insects, roots, and the carrion of the dead world above. By living underground, it has escaped the worst of the heat, the toxic air, and now the freezing cold. It is waiting. It and its kind are the inheritors of this broken world. They are alive. The asteroid did not just end the reign of the dinosaurs. It changed Earth's ecological order, pruning the tree of life back to its sturdiest branches. 75% of all species on Earth are gone. The non-avian dinosaurs, the pterosaurs, the ammonites, the great marine reptiles, all vanished. The devastation is almost absolute, and Earth's ecological order has changed. You feel the profound emptiness of this new era, a world scoured clean of its former masters. The air itself, thin and sharp, carries the memory of fire and the chill of a long, sunless twilight. In the oceans, the collapse of the plankton at the base of the food chain has starved the leviathans, leaving the waters as silent and barren as the land. This great silence is the defining feature of the age, a quiet that allows the faintest signs of life, like the stirring of the mammal in its burrow, to feel like a defiant roar. This extended winter, the impact winter, is a filter, selecting not for strength or size, but for resilience. In the silence and the cold that follows, the long winter eventually begins to recede. After months, or perhaps even years, the dust and the aerosols slowly settle out of the stratosphere. A weak, pale sun begins to break through the gloom, and in this faint, returning light, a new world is waiting to be born. In the empty niches left by the giants, the first green shoots of recovery will begin to appear, and the quiet, adaptable survivors will step out from the shadows. You are standing on ice again, but this is a different kind of ice. It is not the planet-spanning, suffocating shell of Snowball Earth. This ice is alive, a vast and frozen river flowing in a timescale too slow for your senses to register. It is a glacier, grinding its inexorable path down from the mountains, its immense weight carving the very bones of the world, pulverizing ancient rock into fine, silty dust. The cold seeps through every barrier. Wind lifts fine snow and drives it across the valley in pale sheets, hiding and revealing the exposed grey rock in turn. Beneath your feet, the frozen earth is crossed by polygonal cracks formed as the ground contracts. This is tundra and permafrost. Only a shallow active layer thaws during the brief summer, allowing mosses, sedges and dwarf shrubs to grow before winter closes over them again. Ice defines the land both above the surface and deep below it. This is the Pleistocene epoch, a time that began more than 2.5 million years ago. We call it the Ice Age, but that simple name belies the truth. It was not a single, monolithic winter, but a long and rhythmic series of them. Dozens of glacial periods, times when the ice advanced, followed by warmer interglacial spells when it retreated. A planetary heartbeat, a slow breathing in and out of cold and warmth, all driven by the quiet, celestial mechanics of our solar system. These are the Milankovitch cycles, the subtle, predictable wobbles in Earth's journey around the Sun. A gentle change in the tilt of our planet's axis, a slow gyroscopic precession, a gradual stretching of its orbit from a circle to a slight ellipse and back again. Each change is tiny in cosmic terms, but over millennia their combined effect is profound. They alter the amount of solar warmth reaching the poles, tipping the climate's delicate balance just enough to begin the slow, unstoppable accumulation of ice, burying entire continents under frozen water. You walk across ground frozen hard as iron. In summer, its surface will become boggy and busy with insects. Now the winter sun traces a low arc along the southern horizon, offering light but little warmth. And then, through the shifting veils of blowing snow, you see them. Shapes moving in the distance, impossibly large shapes. This is the world of the megafauna, the giant beasts of the Ice Age. A family group of woolly mammoths comes into view, their colossal, shaggy forms moving with a slow, ponderous grace. They are mountains of flesh and fur, perfectly engineered for this frozen world. Their coats are a masterpiece of natural insulation. A long, coarse outer layer of guard hairs sheds the snow, while beneath it lies a dense, soft undercoat of fine wool, trapping a layer of air against their skin. Their ears are small and furry, minimizing heat loss. Their iconic, spiraling tusks, some growing to astonishing lengths, are not just for show or defense. You watch as a large female uses hers with practiced ease, sweeping aside drifts of snow to uncover the sparse, hardy grasses and sedges hidden beneath. They graze on tough plants hidden beneath the snow. Their feeding helps maintain these grasslands by limiting young trees, disturbing the surface and returning nutrients to the soil. Calves remain close to their mothers, while older animals form a loose protective circle around them. As you approach, the matriarch lifts her head and tests the air with her trunk. You stand still. Her low call travels partly through the air and partly as vibration through the ground, where the feet of other mammoths can detect it. After a long inspection, she returns to sweeping snow aside with her tusks. Beyond the mammoths, a woolly rhinoceros clears snow with its flattened front horn. Farther away, a giant deer browses on dwarf willow, carrying antlers more than 3 meters wide. A pack of dire wolves watches the mammoths from a low ridge. These heavily built canids can tackle large prey, but they still look for advantage, an old animal, an injury, or a calf separated from the herd. The adult mammoths close around their young and face outwards with tusks ready. For several minutes neither side moves. Then the wolves turn and trot along the ridge, saving their strength for a safer opportunity. In this climate, even a predator cannot afford to spend energy on poor odds. You turn your attention back to the source of this cold, following the slope of the land towards the great glacier itself. As you draw closer, you can see the true color of the ice. Where it has been freshly fractured, it is not white, but a deep, luminous, impossible blue. This is the color of ancient compressed water, ice so dense that almost all the air bubbles have been squeezed out, allowing light to penetrate deep inside, scattering the blue wavelengths back to your eye. You can see layers within it, thin dark lines alternating with thicker, lighter bands. Each pair represents a single year, the dusty, darker layer from the brief summer melt, and the whiter layer from the compacted winter snows. It is a calendar written in ice, a library of past climates stretching back tens of thousands of years, each layer holding trapped bubbles of ancient atmosphere, a perfect sample of the air from a long-forgotten time. At the glacier's terminus, dirty ice carries boulders, gravel, sand, and silt scraped from the valley floor. As the ice melts or pauses, it deposits this unsorted load in ridges called moraines, leaving a map of former advances across the landscape. Finer sediment escapes in meltwater and settles across distant plains as loess. A cave at the glacier's base will release a cold torrent in summer, carrying another season of ground rock downstream. Now the water is locked beneath ice and the terminus is silent. You climb one of these moraine ridges, and from the top, the sheer scale of this world becomes breathtakingly clear. Ice. It stretches to every horizon. This is not just a single valley glacier, It is the edge of a continental ice sheet. Most of Canada and the northern United States are buried beneath it. So is Scandinavia and much of northern Europe and Asia. In places, this ice is more than 2 miles thick, its weight so immense that it has physically pushed the Earth's crust down into the mantle below. When this ice finally melts, thousands of years from now, the land, freed from its burden, will slowly begin to rebound, rising by centimeters each century, a process that continues even today. But life is not confined to the edges of the ice. You travel south, away from the glacier's chilling influence. The journey takes many days. Slowly, the landscape begins to change. The tundra gives way to a sparse taiga forest, a hardy belt of coniferous trees like spruce and pine, adapted to the long winters. And south of that, you enter the true heartland of the Ice Age world, the Mammoth Steppe. This was a vast ecosystem, an immense biome that stretched from Spain to Canada, a cold, dry grassland unlike anything that exists on our planet today. It was a world of nutritious grasses and herbs, fertilized by the droppings of countless animals and sustained by the dry climate and mineral-rich dust blowing off the nearby ice sheets. It supported a density of animal life that would rival any modern ecosystem, a seemingly endless sea of grass roamed by millions of mammoths, bison, horses and reindeer. And it is here, on the rich plains of the steppe, that you find evidence of something new, something that will, in time, change everything. You find humans. Not our own species, not yet. These are our close relatives, the Neanderthals. You see a small family group huddled around the warmth of a precious fire. They are perfectly adapted to this cold, challenging world. Their bodies are short and stocky, a build that conserves heat. Their faces are dominated by a broad, projecting nose, which may have helped to warm and moisten the frigid air they breathed. They are skilled toolmakers, their hands expertly shaping flint into sharp-edged scrapers and spear points. You watch as they work together with quiet, practiced efficiency. They are butchering a bison, not one they have hunted in a dramatic chase, but likely one they have cleverly driven into a bog or found weakened by injury. Their knowledge of the land and its inhabitants is profound, honed over hundreds of thousands of years of survival. Every part of the animal is used: the meat for food, the thick hide for shelter and clothing, the bones and sinew for tools and thread. Nothing is wasted. At dusk, you sit near their fire beneath a clear Pleistocene sky. Wood smoke and roasting meat scent the air while tools are repaired for the following day. One of the older people scores lines into a piece of bone with a flint edge. You cannot know whether the marks count, decorate, or remember something. Around the fire, knowledge passes through gesture, demonstration, and speech, where stone can be found, how weather moves through the valley, and which plants ease pain. The careful marks do not prove a particular story, but they belong to minds capable of planning, abstraction, and memory far beyond the immediate task of survival. This glacial interval will end as orbital cycles and climate feedbacks bring warmer conditions. Ice sheets retreat. Meltwater raises the seas and forests spread into former grasslands. The transition will not happen in one smooth movement. Cold returns and advances interrupt the longer retreat. Homo sapiens will also move through these regions, meeting and having children with populations of Neanderthals, whose long history here is nearing its close. A small part of that history will remain in the genomes of many people alive today. But that is a story for another time. For now, in the deep chill of the glacial winter, the ice holds dominion. The mammoths graze, the wolves watch, and a small family of humans sits around a flickering fire, sharing food and warmth, their minds just beginning to awaken to the power of symbols, unaware of the immense changes that lie on the horizon. You feel the immense, patient power of the ice. It has shaped this world for 100,000 years, carving valleys grinding mountains into dust and holding the world's water in its frozen embrace. The sheer weight of it has pressed down the land beneath you, a depression that will take millennia to rebound once the great thaw begins. This vast sheet, a continent of solid water, dictates the flow of the wind, the paths of the animals, and the limits of life itself. Its influence extends far beyond its physical edge, creating the cold, dry grasslands where the mammoths and the woolly rhinos roam. Everywhere you look, you see the world as a product of this immense geological engine. The polished rock, the scattered boulders carried for hundreds of miles, the very air you breathe, sharp and thin with cold. It is a world made by ice, for ice. And yet, this colossal force is already in retreat, even if its movements are too slow for any single lifetime to perceive. The orbital clock is ticking, and the long winter of the planet is slowly, almost imperceptibly, beginning to loosen its grip. This slow, inexorable retreat is a rhythm measured in millennia, a geological pulse beating far too slowly for you. You leave them to their fire and their stories, walking back towards the silent, frozen north. As you stand once more at the edge of the immense, blue-hued glacier, you realize that you have been witnessing the planet's final act of purely geological transformation. The forces that will shape the next chapter of Earth's story are not the slow grinding of ice or the shifting of continents. They are stirring in the minds of those toolmakers around their fire. A new force of nature is being born. You are here, not in the swirling dust of the protoplanetary disk, nor on the shores of a primordial iron-green ocean. You are here now. In the quiet solitude of this present moment, the only one you will ever truly know. The ground is beneath you, solid and unassuming. Perhaps it is the floor of your home, the pavement of a quiet street, or the soft yield of garden soil. You have felt its reliable presence a million times, a simple fact of the world. But after our long journey together, through the eons of deep time, perhaps you feel it differently now. Each point of contact is more than just a step. It is a connection, a physical link to the 4.5 billion year story of this planet. The very atoms that make up this ground, this steadfast foundation, were forged in the hearts of stars that died long before our sun was born. The oxygen filling your lungs with each slow rhythmic breath was a gift from countless generations of cyanobacteria, the tiny architects of our atmosphere. The reddish tint in the soil, the iron in a forgotten nail, is the legacy of a planet-wide rusting event, a slow precipitation of oxidized iron from the oceans nearly 3 billion years ago. The silent, colossal forces of geology have spent an eternity shaping this world for you. The drift of continents, the slow-motion crumpling of rock into mountain ranges, the patient carving of rivers through stone, all of it has culminated in this very spot, in this very moment. And you are an intimate part of this cosmic recycling. The carbon that forms the scaffolding of your cells, the nitrogen in your DNA, the calcium in your bones, all were once scattered across interstellar space. They have been gathered, remixed and reassembled by the patient chemistry of a living planet, arranged into this remarkable form. A form that can not only exist, but can feel. A form that can comprehend. A form that can lie quietly in the dark and look out at the stars, wondering about its own origins. Imagine yourself walking through a sleeping city. Towers of glass and steel rise around you, monuments to human ingenuity. They seem entirely our creation, yet they are as much a part of the earth as any mountain. The glass is simply silicon, refined from quartz sand, which is itself the ground-down remnant of ancient granite peaks. The steel skeleton within is made of iron, smelted from ore, laid down in those banded formations on an alien-looking early Earth. The concrete is largely limestone, the compacted remains of countless shells and skeletons from organisms that thrived in warm, shallow seas hundreds of millions of years ago. We are not creators of materials, but merely masterful rearrangers of the planet's elemental library. The city glows, a sprawling network of light that outshines the stars. From orbit, our urban centers resemble new constellations on the night side of the globe. They are part of a new layer of technology and civilization. This human influence is sometimes described with the informal term Anthropocene. It is not a formal epoch on the geological timescale, but it is a useful name for the marks our species is leaving in rock, ice, sediment, and living systems. Consider what this means. In the immense timeline of our planet, the entire history of anatomically modern humans would occupy only the last few centimeters of a kilometer-long measuring tape, a fleeting instant. And yet, in that sliver of time, we have altered the face of the world. Our impact may not yet rival the planetary engineering of the first oxygen-producing life, or the cataclysm of the major asteroid impact, but it is measurable, significant, and happening with unprecedented speed. We have rerouted rivers, drained wetlands, and cleared ancient forests. We have moved mountains, not as a figure of speech, but as a literal consequence of mining and construction. We excavate and redistribute rock and soil on a scale that will be clearly visible in the geological record for millions of years to come. Any future intelligence studying the Earth's strata will find it, a thin, curious line in the rock, rich with unusual plastics, unique radioactive isotopes, and the fossilized bones of our domesticated animals. A line that marks the moment one species began to consciously reshape its world. And we have changed the sky. The composition of the very air you are breathing is subtly different now. Levels of carbon dioxide in the atmosphere have been rising, changing the thermal balance of the planet. The Earth is warming. The ancient ice sheets of Greenland and Antarctica, which have survived countless cycles of glacial advance and retreat, are beginning to melt at an accelerating rate. The oceans, the great stabilizing flywheel of our climate, are absorbing both heat and carbon, which gently but relentlessly alters their chemistry. Let us walk to the coast. You can feel the change in the air, the faint scent of salt. This is the same shoreline, in essence, where you once stood and watched the first rains fall on cooling rock to form the first oceans. The water is different now. It holds more warmth, and it is slightly more acidic. In many parts of the world, the vibrant ecosystems of the coral reefs are paling, bleaching under the strain of these new conditions. The ocean is in a state of flux. But then, it always has been. Change is the one constant in Earth's long story. The difference, this time, is the cause. The difference is us. You find a place to sit on the sand, still holding the faint warmth of the day's sun. The waves arrive on the shore with a gentle shushing sound. It is a rhythm that has not changed in billions of years, a heartbeat set by the gravitational pull of a moon that was once part of the Earth itself. As you listen, you think of the future. Our species is resourceful and resilient. We have weathered ice ages, supervolcanoes, and pandemics. We will likely endure. But the world we are shaping will be a different one. It is already a world with fewer giants. The great megafauna of the last ice age, the mammoths, the woolly rhinos, the saber-toothed cats are gone, their disappearance coinciding with our arrival on each new continent. The pattern of habitat loss and extinction continues today. Many of the magnificent species alive now may not survive this period of rapid change. Extinction rates are far above the natural background level. It is not yet a devastation on the scale of the Great Dying or the end of the dinosaurs, but it is a significant pulse, an event that will be starkly clear in the fossil record. Yet life will go on. It is the most persistent force this planet has ever produced. After every fire, every freeze, every impact from space, Life has returned. It adapts. It diversifies. It radiates into the empty niches, exploring new evolutionary pathways. In 10 million years, or 100 million, the Earth will be teeming with life once more. The continents will be in different places, the climate will be unrecognizable, and the dominant species will be creatures we can barely imagine. They will know nothing of us. Our cities will have long since eroded into dust, our monuments crumbled. We will be just another thin layer in the rock, a fossil curiosity for a future civilization to perhaps discover and to puzzle over. The story of that layer, however, the tale it will tell of our time here, is still being written by the choices made in this unique, self-aware moment. You stand and brush the fine grains of sand from your clothes. You look up. The deep velvet of the night sky is softened by the city's glow, but a few of the brightest stars and planets still pierce the veil. You remember that their light has travelled for years or centuries or millennia to reach your eyes tonight. Those are the same silent, glittering witnesses that shone down upon the Hadean Earth, the Cambrian seas, and the Age of Dinosaurs. They are older than our world and will outlive it by billions of years. Their existence is a reminder of a scale so vast it borders on the eternal, a cosmic indifference to our small, terrestrial dramas. But you are not indifferent. You are here. You are conscious. You care. Because you are not merely an observer of this story, you are a participant. You are the current, thinking, feeling edge of a narrative that has been unfolding for 4.5 billion years. And this chapter is not yet complete. The final words have not been written. You walk home through quiet streets, past darkened windows where others are sleeping, mostly unaware of the deep story beneath their feet. The knowledge carries weight, but also the simple privilege of being alive, to understand a little of it. You are alive. Right now. On a planet that has been a hellish ball of molten rock, a snowball encased in ice, a sweltering jungle of giant ferns, and a frozen steppe roamed by mammoths. A planet that has endured bombardment from space, colossal volcanic outpourings, and multiple mass extinctions. A planet that is, against all conceivable odds, still here, still turning, still vibrant with life. And you are a part of that life, made from the dust of ancient stars, shaped by the patient hand of evolution, standing on ground that has taken an eternity to form. You lie down, settling into your bed, the same place this journey through time began. The world beneath you feels solid, stable, and permanent. But you know now that this is an illusion. It is a planet in constant, graceful motion. The ground beneath you is adrift, a piece of a tectonic plate floating on a sea of molten rock. The continents are still shifting. The mountains are still rising and eroding. The oceans are still breathing in and out with the tides. It is all changing, as it always has, and as it always will. In the unimaginably distant future, the continents will merge again. The oceans will change shape. In about 1 billion years, the sun's steady brightening will make Earth's surface too hot for liquid water. The oceans will slowly evaporate into space. The surface will bake. And Earth, our beautiful, complex, blue marble, will become a silent, barren rock once more. But that is a story for 1 billion years from now. For tonight, the planet is alive, and so are you. Sleep well. Across its surface, a soft luminescence traces the arteries of human connection. The gentle glow of countless cities and towns pulses in the darkness, a vast, interconnected network of quiet dreams. Each point of light is a home, a hearth, a place of rest where a story like your own is unfolding. This has been Sleepy Stories.